Become an embedded system engineer with this 60 days challenge. Are you looking for a quick start to a new career? A 60-day challenge in which you will learn how to design embedded systems from scratch. You don't need prior knowledge of electronics, programming, or hardware. Now I want to help you learn how to become an embedded system engineer in this challenge 60 days. This challenge is a quick learning course for those who want to become an embedded system engineers. This embedded system course is a jam-packed with 60 days of lessons that take you from complete embedded systems novice to feeling confident making your own embedded systems product or starting a career. While you don't have to finish the course in 8 weeks, we have set up the course where each section is for 1 week. The course is designed to be completed in 60 days. It covers programming, microcontrollers, communication protocols, circuit design, PCB design, and 3D modeling and simulation. It has project-based and it's a lot of fun to learn. Now, throughout this course, you will learn various embedded systems engineering skills like how to read AVR assembly code, how to read datasheets, and how to program microcontrollers. By reading the content and reviewing the exercise course, you will be able to learn how to be an embedded system engineer. This course is not only about programming, but also about designing all aspects of a hardware system, including hardware connection. What you will learn in this bundle. First, we'll talk about embedded C. Then we'll talk about programming and using Arduino. After that, we will cover 8-bit microcontrollers like BIC microcontroller. We will also talk about communication protocols, and we will cover circuit design and simulation from scratch. After that, we will talk about 3D design and simulation to make your own 3D models. Then we will go to PCB fabrication from scratch. Learn everything about embedded system with this challenge. In day 1 to 10, we will get over C programming for embedded system from scratch. Then, in day 11 to 20, we will talk about Arduino microcontrollers in a step-by-step manner. After that, in days 21 to 30, we will go over 8-bit BIC microcontrollers with more than 8.5 hours of lessons. Then, we will cover communication protocols from day 31 to day 37. Then we will go from day 38 to 44 to circuit design and simulation. We will also cover from day 45 to 50 3D design and simulation. After that, in day 51 to 60, we will go over PCB fabrication. Now, why you should take this course? You will learn on your own time at your own pace. This course is also accessible for beginners. Learn the skills to design, develop, and test embedded systems. This course will help you master all skills required to become an embedded system engineer. Hello and welcome to this new lesson. Now, you might wonder why there are quizzes and assignments as you go in this course that asks you for things that are not yet explained. This is the goal of this challenge. Now, we are doing this because sometimes you need to go out there and search for the information. As an embedded system engineer, Google should be your friend. And in this lesson, I will teach you how to search for things that you know nothing about. Let's say that you encounter a quiz question or an assignment that asks you to do a specific thing or to answer a specific question that wasn't covered in the lectures. We are doing this in purpose to make sure that you have the skills to search Google and find the answer and understand it on your own. We do teach you a lot in this course, but we won't be able to cover 100% of the knowledge in the world. So we are following this approach to make sure that you can actually search for things and find the actual answers. So here is Google. The first thing that you need to do is to ask Google. Now, Google doesn't care about propositions, so you can easily type anything without is, are, was, for, at, and these things. So let's say that we encountered a quiz question that asks us about how to print a text on the console window using C programming. So you should write print on console C. Now on is something that you can skip. So once you write print console C, you will find a lot of results. Usually you will find Stack Overflow, which is a website for developers where they ask questions and they find answers. Now as you can see, it's showing you how to print something out to the console C code example. You can click on that and you can see the result. As you can see, this is the print statement on console. And this is how easy it is to find things that you know nothing about using Google. Now, let's say that there was a quiz question that asks you what is a for loop. So you can write for loop in C. And you can remove N. That's it. So C for loop with examples, and you can check any of the results on Google. There is tutorials point, Java point, geeks4geeks.org, which is a very professional website for C programming, but we usually recommend Stack Overflow. As you can see, for loop within a for loop in C, and you will most likely find a lot of people answering the questions there. Now you can even ask your own question by creating an account and post your code if you have a problem. This is how easy it is to search for things that you know nothing about, so don't be surprised if you found a quiz, assignment, or a homework in this challenge that was not yet explained in the lectures. This is something normal, we do it on purpose, so make sure to use Google, and most of the engineers use Google for 70% of their, let's say, questions. And the 30% is simply how to plan your project. Coding is simple if you know what you need to do. That's it for this lesson. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to download and install the software that we will use to write codes in this course. Now there are a lot of software that you can use to write C codes, but the one that we will start with and the one that we would like you to start with is called Notepad++. As you can see, it's basically a notepad. Simply click the download and choose the latest version. Choose depending on your operating system. As you can see, they have support for almost all of the operating systems. Simply hit the download button and your download will start. Now click once to start the installation process. Choose your language, click OK. Now click Next, click I agree, Next, Next, and you can create a shortcut on desktop, then click Install. It won't take long, it's a very small software. Simply leave the run and hit the Finish button. Now here we will write our C codes. Now in this white area, and you can choose the language that you are writing for from the language drop down menu. Simply go to C and select C. Now you are good to go regarding writing codes, but we also need to compile our codes. In order to compile the codes, we need to use a compiler called GCC compiler. So again, go to google.com, and in here write GCC compiler. As you can see, GCC, the General Compiler Collection, you can open it up, and here you will find a lot of information and a lot of resources about this compiler. This compiler includes front ends for C, C++, Objective-C, Fortran, Ada, Go, and D, as well as libraries for other languages. Now, you can select any of these versions, but this page feels overwhelming for a lot of people. So we will go with a direct installer. So go back to Google and write min gwc compiler. Once you write that, you will see that we have a sourceforge.net.exe file that we can download and install. And we also have the original website called min-w64.org. This is it. Now you can go to the downloads section, make sure that you are inside this website. And once you are inside the downloads section, scroll down until you reach this point, min-gww64 builds running for Windows, and it supports C, C++, Fortran. Click once, and here you will find the installation location. As you can see, min-gw builds, click on the source fork, and here it is. Now, make sure that you are installing the software from this location, source fork, and this name. Click once, click yes. Now click next. Leave it to the default, click next, change the location. We need it to be inside the C directory and leave everything as it is. C min-gw-w64 / or backslash. Now click next. Now make sure that you memorize this location. Click next, and it will start the downloading and installation of the compiler files. Now there are other options to write C codes, but this is the first one, and we'll explain all of them in this section. Now you are free to choose which one you want to go with. Now once you are done, click next and finish. Now if you went to the original folder in which all of the files were installed, it's inside our C directory, as you can see here. And here we have the min-gw, as you can see, and here we have the .bat file. This is the original file that we need, and we need the bin folder. So make sure that you are inside this folder, C min-gw-w64 min-gw32 bin. Click once and right click, then copy. Now we need to make Windows understand that we have a C compiler installed. Now you need to go to your desktop, right click on your PC, select Properties. Now select Advanced System Settings. And from this window, you can select Environment Variables. You will see this list. Go to the System Variables down here. Scroll until you reach the path. Then hit the Edit button. Now this is a list of paths. And what we need to do is to add a new path and paste the path for our GCC compiler inside here. Now once you do this, you can simply hit the OK button, and this is how to make Windows understand that we have a C compiler installed. Click OK and OK and close this window. Now you can go back to the Notepad++ and write any C code. Simply write void. I will write anything like int, in. Let's write void here. And let's include a library. We will talk about that in the coming lessons. Now once you are done with this, you should be able to go save your file as a C file, test.c, and you can go to the file, select open containing folder, and simply select cmd. Now you will see the command window. All what you need to do is simply write gcc test.c. And as you can see, the code did compile. Now if you wrote gcc, as you can see, fatal error, compilation terminated. This means that we have the GCC compiler installed. Now if you want to print something, you can simply write print if hello and save the file. Go back here, write GCC, and once you have compiled the file, you can simply write a.exe and you will see the printed word, as you can see, hello. And we will explain these steps in the coming lessons. But this is how to make sure that your compiler is installed. Now we will use Notepad++ and GCC compiler, the command window, the cmd, to compile our files. And if you faced any problem, I'm here to help. Please inform me and I'll help you install the software. In the next 2 or 3 lessons, we will explain different options to write C codes, not just using Notepad++, but we have other options as well. Thanks for watching this lesson. See you next. Hello and welcome to this new lesson in which I'm going to show you the second and easier option to write and compile C codes. Go to any web browser and write online GDB. This is the word online GDB. Now once you do that, you will see the first result, a website called onlinegdb.com. Click once and you will see a compiler. As you can see, this is the area where you write codes. And from the top right menu here, you can select the language, simply hit the C language and run. Now once you run this compiler, you can see the word. We print F hello world, so it will print hello world down here. So this will be your command window in which you will see results. And this will be the area where you write codes. Now, if you have any problem in the code, it will indicate that in this window, as you can see. So it's a very professional online compiler that you can use. Now, what we recommend is that you go and log in using your Gmail account or sign up with your Gmail account or Facebook account or GitHub account, or simply by writing an email and password. I usually prefer going with Google, so we will sign in using Google. Now Once you sign in using your Gmail account, here it's asking me for my security code. So once you are in, simply write the code. Once you are in, you will see a projects window or tab here, or you can create a new project. Now, if you created a new project, you can easily save the new project to your library and you can go back to that project anytime. So simply hit the save button, name the project testing, click save. Now we have a new project called testing, and you can create more than one file inside the same project. So let's call this test. So now we have a C project with more than one file. Now, once you hit the save button, you can go to my projects and you can see the testing project that you made. This is a very, let's say, comprehensive platform. It's for free as well. And you can access it from your mobile phone if you don't have a laptop and you want to start coding in C. Now, what we will do is we will create a classroom and we will add the link to this classroom so that you can submit the homeworks for this course inside this classroom. As you can see, you must create an account in order to submit the homework, save your projects, and save your work. That's it. Now, once the homework is submitted, we'll explain to you how to access the homework and how to solve it. Thanks for watching this lesson. If you have any question about how to create a new project and how to write a C code inside this platform, feel free to ask. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to show you how to download and install Visual Studio Code and how to enable C and C++ programming using this software. So the first step is go to any web browser and write Visual Studio Code. Now, as you can see, it's basically a software provided by Microsoft, and you can simply download for Windows by clicking here. Now, as you can see, this is a quick overview of the software itself, and it's asking you if the download not starting, try this direct link. Now, once you click on the direct link, the download will start, as you can see here. I will use another software to download it. Okay, now as you can see, the download started. It won't take long, it's about 76 megabytes. So after that, you will have the Visual Studio Code setup file, and we just need to install it. Now, Visual Studio Code is a software used for writing codes in a lot of programming languages like C++, C#, Java, Python, PHP, and Go. Click Open, click Accept, Next, Next, Next. And if you want to create a desktop icon or add Open with Code action to the file menu, you can click on these and then install. And as you can see now, it's extracting the files. Then it will start the installation process. Usually it doesn't take long. It's a very light software, but it has a lot of capabilities. Now, as you can see, we have the software installed. Click Launch Visual Studio Code and hit Finish. Now, once you are here, then you are good to go. You can choose the look you want. We can go with the light or the dark. Now, since I'm recording videos, going with the light one is better than going with the dark one or the high contrast one, but most programmers prefer the dark one. Now, I will choose the light because it will show you the codes in a more clear way. Now, once you are done, you can also browse color themes. There are other themes as well. Now, you can complete this checklist or go to the next section. As you can see, redefine your editing skills. You can open Editor Playground to change different things. Now, you can also go here to this area and create a new file, as you can see, or open a folder. Now, once you have this software installed, then you can go to the next step. The next step is to install the extension, C++ extension. So go here to the extensions on the left side, and in the search bar write C extension. Now, as you can see, here we have the C++ IntelliSync extension. This is the first one, and this is the second one, and this is the third one. Now we need this one. We don't need this one. Just make sure that you have the one that says C++ Intel Sense debugging and code browsing. Now once you are inside this, you can click the install and the installation process will start. Now you need to wait few seconds for the installation process to finish, because now it will call the extension from Microsoft servers and download it, then install it in your or on your operating system. Now once you see the uninstall button, it means that we have the extension installed successfully and we are done with this step. Now the next step is to install the C compiler. We already did that in a previous lesson, so we will do it quickly in this lesson. So go write min gw-w64 and go with this link. Now we have more than one. You can choose the minimalist. So min gw-w64 minimalist, and click once on the source fork here, and you will see the download page. Click the download button. Make sure that you have this name on your browser and hit the download. Now it shouldn't take long, as it is an online compiler. So here it is. Click once. Now you need to follow my steps as it is. Click install. Now once you click install, you need to choose the location where you want to save this file. So let's call it min.gw, or you can add 2020, whatever you want. I will leave it as it is, min.gw, and click continue. Now make sure that you have this location memorized or copy it. Now click continue. Now wait a few seconds for it to call the list of things available on the server. Now click continue, and you'll see this list. Here you can see the list of things available for you to download. We need to download this, mark for installation, and we need the GCC G++. Now make sure that both of these are selected, and once you are done, go to the installation and hit apply changes. Now it will ask you if you are sure. Click apply, and it will start connecting to the server and downloading and installing all of these components. Now that shouldn't take long. Now once you are done with the download and the installation of the GCC compiler, you need to go and set the environmental path. So make sure that you go to the start menu and write environment and hit here. Now sometimes these buttons are not enabled by default. So in this case, you need to go to your PC, right click, select properties, and from there go to the advanced system settings And in here, you can see environment variables. Click once, and you will see this list. Now go to the system variables, make sure that path is selected, double click on it, and you will see this list. Now all what you need to do is simply click new, and paste the URL for the main GW, and make sure to add the pin folder. Now, once you are done, since I already have it here, I will delete this one. I already have it here, as you can see, main GWW64/pin. You make sure that you are referring to the pin folder, or the bin folder, sorry. Now click OK and OK. Now the last step is testing. So go back to the Visual Studio software, which is this software, and let's start by making a new folder to store our C codes. In order to do this, I will go and add a new folder to the C directory. Let's call it C codes. New folder. C codes. Double click, and here it is. This is our folder. Now, once you have this folder, go back to this menu and click Open Folder. Go back here and select the folder. Now, once you select the folder, it will ask you if you trust the authors or not. Select Trust, and yes, I trust the authors. Now we are inside the folder called C codes, and we can start writing our C codes inside it. So click here, New File, test.c. Now inside here, we will write the same code that we wrote before, #include stdio. Okay. Now int main void. Now once you are done, simply go here and write printf and write hello testing. Now when you finish creating your first C code, simply right click on this C code and you'll see a list of items. First, you need to make sure that you have already saved your file. Now, as you can see, do you want to install the recommended extension for C? Click install. It's written on the right side of this window. Now here we have the C++ extension. As you can see, it's installing a lot of extensions related to C programming. C++ extension back. But even without the extensions that are now installing, since we already installed this extension, you can go to your C file, click Run, and hit the Start Debugging. Now it will ask you if you want to debug using the GDB or the Windows. Select GDB. Do you want to compile using GCC compiler or any other compiler? We will compile using the GCC compiler. Now, as you can see, it's compiling the code. As you can see, exited with code 0, and we have 0 errors. So the code did run correctly. So if you want to run the code without debugging, simply go back and hit run without debugging, and it will simply run the code without debugging the errors. Now, if you want to make sure that the program did run correctly, you will see a .exe file beside the main file. And this is the executable file that you can run and will show you a command window. Now, right click on it, open Reveal in File Explorer, and double click. It will show you a command window, but it will quickly disappear. Now, if you want it to stay, you need to add a scanf sentence. Now, save the code and run the code. Now, once you are done with running the code, you can go again and open up the text or test.exe file, and you will see the hello testing word, which is this word. That's it. This is how to enable debugging on Visual Studio Code. We won't use this software, we will use the Notepad++, but this is something for you to know. Now, some people might want to see the output in this window. Like when they are running the C code, they need to see the output inside this output window, not inside the .exe file that we just launched. And to do this, we first need to do the following. You need to go to the tasks.json file, which is basically just this file. And here you will see the label line gcc.exe build active file. Now, if this is the written thing inside your label, you need to go back to the JSON file, which is this file, and you just need to add the external console here, change it to true. Click save, and now hit the run. As you can see, now you can see the output result for your code, hello testing. Now it did run the output directly after running our code. And this is one of the easiest way to implement this. If you have any other questions, I'm here to help. Thanks for watching this lesson. See you next. What is C programming? In this new lesson, we'll talk about a C program, the basic structure of a C program, and what is a C program is made from. C is structured programming. It means that the C program is composed of small parts we call function, and you will hear the word function a lot while you are programming in C. The first function to be executed, which is the entry point of the program, is called main, which is the main function. Some functions may be a standalone file for organizing, and these are called library. Now, the basic structure of a C program is basically the main function. Now, this main function can be or can include one or two functions. As you can see, function 1 and function 2. Now, the C program that has more than one function, these functions can be composed and stored inside a library. And we will create our own libraries at the end of this course. What I need you to understand at this point is that your C program will have a function called the main function. This is the first function to be executed in our program. Now, this might be vague for some people, but we will see it in action in the next lesson. Now, library is basically a collection of functions that do a specific thing. Like you can have a library that print things on your display. You can have another library that has functions that help you read data from the user. And this can go on and on. So a function is a piece of code that does a specific thing. The main function is the first function to be executed in our program by the compiler. The library is a collection of functions that does a specific thing and that you can easily use inside your code. Now, let's take a quick look at a simple C code. As you can see, this is the first C code that you will see in our course. The first thing up here is called a multi-line commit. Now this multi-line comment, it means that this is not a code. This is something you usually write for yourself, like to remember what is this code is all about. Now, to write a multi-line comment, you need to make sure that you have the backslash and asterisk. Now, in this area, as you can see, we have a backslash and asterisk, and you must end it with an asterisk and backslash. This is the beginning and the end of a multi-line comment. Now, anything written between these two signs is called a comment. So this is not a code and won't be executed as a code. This is only for you to see. Now, the second thing here is the include command. Now, when you want to include any file, any library, or anything inside your C program, you must use #include. This is called #include. Now, usually it is followed with these signs and the name of the thing that we want to include. Here we are including a file called stdio.h, and we don't want you to understand at this point what's the meaning of this file. All what you need to do is that when you want to include a library or a file, you must use the #include, #include, and the name of the file between these two signs. We also have something called a single line comment. Now, we already mentioned the multi-line comment up here in this area, but what if you want to make only one line comment, not multiple line or multi-line comment? You can easily add two backslashes here, and these two slashes will make this line a one-line comment. So anything that you write in this line will be considered as a comment, and it won't be executed. Now, we already mentioned that your program must have a main function. The main function is basically the function that will be executed first in our program. As you can see, this is the function name. Now, void and void are two words that have a meaning, but we will not explain them at this point. You just need to know that you must add two parentheses, add the word void between them, and leave a space here and add the word void before the name of the function. Now, this is a curly brace. This is the opening and the closing of the curly brace. Here we added another multi-line comment called the main function and pass string to it. Now this is the main function. And inside here, we are writing our very first C code. This is a printf, and from its name, it's basically for printing text on screen. And as you can see here, we are printing this text, hello C world. Now you must add two parentheses and two, as you can see here, quotation marks. Now these two quotation marks will include the text that we want to print in here. Again, this is how to write your very first C code. Now, anything that you write inside the printf two quotation marks will be printed on screen. And to make things more clear, let's write this code and try to execute it as our very first C code. Now, we already mentioned that we will be using a website called OnlineGDB for some of our exercises. Since this is the first exercise, we will use it, but you are free to use the Notepad++ as well. Now, we already mentioned that in order to write a multi-line comment, you need to add these two signs and close them with these two signs. Now, let's write. This is our first C program. Testing and printing. Now, these two lines are basically a comment. It's a multi-line comment. Now, let's add a single line comment. This is a single line comment. Great. Now let's start by including the library. So we will include the stdio or standard input-output library to allow us to print on screen. So write include and the larger and less than sign and add the library name. That's it. Now this means that we are asking the compiler to include the functions inside this file inside our C program. Now let's write our main function. Usually, the best way to write things is by writing the syntax, then writing the code inside it. I like to write the syntax in one line, as you can see, void, leave a space, then write main, which is the name of the function, then add two parentheses, this one and this one, add the word void between them, and add two curly braces. Once you have this, simply put your mouse here, press enter, put your mouse between the two curly braces and press enter. This means that you are good to go. Now, let's print something. What we need to print here is this is our first C code. Now, you need to choose the language from the top right corner, select C, and hit the Run button. As you can see, this is our console window. This is our first C code, and it's working properly. Now, if you did reach this point and you managed to write this, and you saw this output, means that everything went well for you. Now, you can copy the whole code, go to the Notepad++ here, create a new file, and paste your code. Make sure to choose the C language as your default language, and save your file. Leave it as new. Now, go to the file. If you already followed our installation video in the download and install software section, you should be able to use Notepad++ for compiling your code. So click CMD, and once you see this window, you need to write GCC. After that, you need to write the name of the file, new3.c. Now this means that we are asking the compiler to compile our C code, which is the first step in, let's say, playing or making sure that our code doesn't have any errors. Now, if you compile the code and you didn't see anything, it means that everything went well. Now, your documents folder will have a new file called a.exe, which is basically the file that has the output of this C code. Press enter, and you will see the very same code. This is our first C code. Now let's repeat these steps. Write GCC, which is the compiler, the file name, then a.exe, and you should see the output. If you saw the output, means that everything went well for you. Now if you compare this output with the output from before, you can see that they are identical. The same sentence here is written in our CMD or command line window. That's it. This is the end of our first lesson. Thanks for watching. If you have any questions, I'm here to help. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about comments. Comments in C are basically an non-executable text used to provide documentation for the code. It provides clarity to the C source code, allowing others to better understand what the code was intended to accomplish. It is always recommended to use comments in your code. We already mentioned that we have two types of comments, the single line comment and the multi-line comment. The single line comment is basically any line preceded by two forward slashes. As you can see, the forward slash is the sign that you can easily write using your keyboard, and this is the final shape, two forward slashes and this is your comment. While the multi-line comment is any text starts with a forward slash followed by asterisk and ends with an asterisk followed by a forward slash. And this is how it looks. Forward slash asterisk and asterisk then forward slash. This is the multi-line comment. Now we already showed you how to write these comments, but let's refresh our memory. Now as you can see, this is the forward slash followed by an asterisk, and this is an asterisk followed by forward slash. Now if you close this, you can see that these two comments are together, and these two forward slashes are followed by one line, which is the one line comment. Now another piece of information that we can mention is that when you write two forward slashes anywhere, even inside the main function, they will be treated as a comment. Now if we want to comment this line, printf, we simply add two forward slashes, as you can see here. Now these two forward slashes will mean that this sentence won't be executed. So let's save this file. Let's open it using cmd. We need to use the same name, gcc one first c code.c. And as you can see, because our file name has all of these spaces, it won't be compiled correctly. So in order to compile a C code, the name must include no spaces. And this is a very important note. Now save your file again and remove the spaces. Now let's do this one more time. Let's go to file, open cmd, and write gcc, write the file name one first c code.c. Now as you can see, we didn't leave a space. Okay, let's leave this space. Now the code compiled correctly. If we try to run the exe, nothing will be printed because we commented the line called printf. This is our first C code. Now if we remove the comment, save the file again by clicking here, and went back to this command window, we can run the command again, and we can use the a.exe to see our output. This is our first C code, as you can see in here. This is how you can use multi-line comments or single-line comments, and this is how you can use them in debugging as well. So if you suspect that this line is causing a problem, you can simply comment it using single-line comment with two forward slashes, or double-line comment using the forward slash and asterisk, then the asterisk and forward slash. That's it. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about a very important topic in C. Strings in C. Strings in C are basically a way for you to explain or type things. It is comprised of a set of characters that can also contain spaces, special characters, and numbers. Now, in C, string is represented between double quotation, like these two double quotations, as you can see in this image. This is a string, or this is simply anything that you write between these two double quotations will be considered as a string. Printf function, the function that we already used twice, will print the string passed to it as it is. It's called string literal. Now, escape operators may be used inside the string, like the backslash, as you can see in here, with a letter following the backslash. This operator may insert tab, new line, or quotes. As you can see, if you use this one, it means that at this sign, please add a new line. If you use this one, means add a horizontal tab after this location. if we use this /v, means that we need to add a vertical tab inside our string. If we need to show the single quotation or double quotation inside our string once we print it, we can use the /single quotation or /double quotation or double quote. Now, things might be more clear when we execute them. So let's try this out. Let's include, as usual, the stdio.h library and write the main function the same way we mentioned before. Press enter here and press enter here and write your code here. So print f. Here, between the double quotation, we will add our string. This is our string. Now, if you want to print a string and add a new line, this is the second line. Now, without adding the /n, this text will be printed like this. Okay, let's add the semicolon. As you can see, this is out string and this is the second line. Now, they were printed on the same line. If we want to add a new line, at the end of the first line, you can add /n and run again. Now, as you can see, this is the first text and this is the second text, and we added a new line here. Now, let's say that we want to print the single quote or double quote. If you added the single quote here and try to run the code, as you can see, it can directly be printed. Now, in some compilers, this will not print directly. It will cause an error, so you need to add a slash and then run the code. As you can see, it is printed as well. Now, what if you want to add the double quote? You can add the double quote here, but if you try to run the code, it will show you an error, as you can see. Now, this error is caused because we know that the string is something we wrote between two double quotation. And since we added a quotation here, it is considering that the string that we want to print is this string, and it's not recognizing this part of the string because it's not included in the first double quotation area. So to make sure that this won't cause a problem, we can simply add a slash. Now when we run the code, it will print the double quotation or the double quote. Now the single quote is printed, the double quote is also printed. If you want to add a space, a tab space between these two words, we can simply add /t and then run. As you can see, /t added a horizontal space between these two words. Now this space can be either 4 or 8 depending on the compiler. Now, we also mentioned the vertical spacing. If you want to add the vertical spacing, here we add the horizontal spacing. Simply add /v and it will add a vertical space between this part of the text and this part. Now click run and you will see that this is printed on the first line and the second line is printed here. So it added one vertical space between these two lines. These things that we wrote here, 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 and here, and here are called escape characters. Now, escape characters are written using the backslash, not the forward slash. As you can see, the comment, the single line comment is written using the forward slash, but the escape character are written using the backslash, so it can be /t, /v, /single quote, /double quote, /n. These are the ones that we introduced in this lesson. /t will add a horizontal spacing. /v will add vertical spacing, as we saw here. /single quote will add the single quote or will print it on the text. slash double quote will print the double quote on our text, slash n will add a new line as we saw here. We added slash n here and it inserted a new line, so these texts are not like printed on the same line. And this is how you deal with string. Now, to print string, we already mentioned that you can use the printf function, and this is a good piece of information that we need to mention here. Printf function takes two, as you can see, parentheses, and inside the two parentheses, you must print two double quotations, and end it with a semicolon. This is the syntax for printf. Now, printf function is a function defined inside this file. It's called standard input output .hex or header file. And we will talk about header files in more details in the coming sections. But what you need to understand is that without including this header file, our main function won't recognize the printf function that is used to print text. And print here means printing. F here means format. Now, this is the string literal. So print format will print the text or the string as it is, as we saw here in the output window. That's it. Thanks for watching this lesson. If you have any questions, please ask in the Q&A board. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about variables in C. Variables in C is basically a place that holds a piece of data. So we all know that memory inside our computers or in embedded systems, microcontrollers, will hold variables. Now, we won't go into the details how memory processes variables, but all what you need to know is that a variable is something that holds a piece of data. Its type varies in data and size that needs to be saved. In most, let's say, use cases in embedded systems, we have primitive data types. These primitive data types are floating types, as you can see in here, and decimal types. The floating types is the float and double, while the decimal types are the character and the integer. Now, the floating types will hold information that has a float, like 3.2, 1.4, and these things. Normally, the float size is 4 bytes, and this is a very good piece of information if you want to keep track of your memory, especially in embedded systems. While double holds the same type of information that a float holds, but the size is doubled, 8 bytes. That's why they are called floating types. Decimal types, on the other hand, are the character and integer. Integer is the most commonly used data type in C. It's about 1 byte in size, while the character is about 8 bytes in size. Characters usually used to store characters like A, B, and C, while integers usually used to store numbers. Float is used to store numbers with a floating point like 3.2, 1.2, and these things. And these are the most commonly used data types in C. We call them primitive data types. You can split them into floating types and decimal types. Floating types are float and double, while decimal types are characters and integer. We use them to store information like a username, a password, or the calculation result. You need to take a note that data types may vary from each compiler to another. So, in one compiler, an integer can take 1 byte. In another compiler, an integer can take 4 bytes. Now, the next thing that we need to mention is the syntax. How do we define variables in C? To define a variable, you need to follow a specific syntax. First, you need to write the data type, which is the first piece of information in the line. The data type is character, integer, float, or double, depending on what type of data you want to store inside it. Then you must leave a space after the data type. After that, you can write the name of your variable. Here, the variable name is x, y, and z. Now the next step is defining or choosing whether you want to add an initial value or not. Now, if you want to add an initial value to your variable, you can simply add the equal sign and add the value. And you must end the line with a semicolon, like every line in C must end with a semicolon. Now, in the first line, we define char and initialize it with the value 9. While in the second line, we initialized an integer, named it y, and the initialization wasn't done. In this case, it will have a random value, we call it a garbage value. And this is not a use case that we would love to happen, so usually we initialize all of our variables. Here we are defining a float and initialize it with a floating number like 6.52. Again, we prefer to initialize all of our variables to an initial value of 0, let's say, if you don't have a specific value in mind, but don't leave it uninitialized. Otherwise, you will end up with a garbage value. Now let's see what will happen inside our memory when we initialize a variable. Now let's say that this is our memory. Now inside this memory, we have different areas, places, and we initialized a variable called x with an initial value of 5. Now what the compiler will do is it will go to the RAM or memory. It will name this location x and will give you an initial value of 5. When we initialize another variable, we call it y, without adding a value, it will go to this location or this memory. It will say this is y and it won't give it any value. Now, whatever the previous value that was here it might be assigned by default to this variable, and we usually call it a garbage value. Now, since integer takes only 1 byte, I gave it 1 byte, so this is 1 byte of memory. But let's say that we want to define a character m, and let's not give it a value. Now, when we go to memory and we want to define m, it will take this byte and this one and this one and this one. So depending on how many bytes the character will take, which is 8 bytes, it will take 8 locations. So it will take also this location, 1, 2, 3, 4, 5, 6, 7, and 8. So it will take all of these locations because it takes 8 bytes, while integer takes only 1 byte, and this one takes only 1 byte. So y is 1 byte and x is 1 byte. So in total, these three variables took 1 byte of memory plus 1 byte of memory plus 8 bytes of memory. In total, they took 10 bytes. And this is a very good piece of information, especially when you are dealing with systems that have low memory size, like in embedded systems. 10 bytes for 3 variables. Again, if we haven't defined anything here, like we haven't said equal 5 or something, we just end it with a semicolon, this will be a variable that we didn't initialize, so it will take garbage values. And we call them garbage values because these values are values that we haven't set, and it might be a previous value from a previous variable declaration in memory from any other software. Now let's test this out by going to the Notepad++ and typing some variables. Now, as usual, hash include the stdio.h and write void main void, and between the two curly braces we'll start typing our variables. Let's change the language to C, and int x equals 0, int y, character z equal 10, float d equals 10.5, and double c equals 34.555. These are the different type of variables. These are initialized variables, and this is an initialized variable has garbage value. Now some compilers say or define the garbage value as 0. Others leave it like to be a random value from memory. But the better use case or the better programming practice is to define this to 0, writing this equals 0. And we already mentioned that you need to add the data type, leave a space, add the variable name, add the equal sign, add the value, and end the line with a semicolon. That's it for this lesson. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to cover some rules in naming variables. Now, the first rule is that a variable may contain the following. It may contain underscore, it may contain a number between 0 and 9, it may contain capital letters from A to Z, and small letters from A to Z. The first character of a variable should contain an alphabet or an underscore symbol, so the variable name cannot start with a number. For example, it can be integer A4 or integer 4A. Now, the 4A is the wrong one. Let's mark these. As you can see, in A4 it started with a letter, while in 4A it started with a number. So a variable name cannot start with a number, as we already mentioned. It can start with either a letter or underscore. So this is the wrong one. Now, blanks and commas are not allowed. And blanks is basically when you write two words and you leave a space between them. Commas are also not allowed, and we are going to see these in action in a few seconds. Variable name should not be reversed or reserved word. Now, reserved word is basically a word that is reserved for our compiler, like printf, for example, or int. So there is no way that you can name a variable int because int is already reserved for our compiler as an integer. So blanks, commas, and special symbols are not allowed, with the underscore as the only exception. So any special symbol is not allowed except for the underscore. Example, the @ sign, the asterisk, the dollar, the plus, and many more signs are not allowed. A variable name cannot be repeated in the same scope. So if you have named a variable x, you cannot create a new variable and name it x as well. The variable name must not be reserved word as we mentioned earlier. Now, let's see these things in action. Now, as you can see, here we are inside the notepad. You cannot name a variable and with a reserved word like int. Int is basically the integer data type, and you cannot name it float. All of these words are reserved for the compiler. You also cannot name a variable starting with a number. This will give you a compile error. You can name it A9 starting with an alphabet, and it will work just fine. We already mentioned that you cannot add special characters like this and this and this to the variable name. However, if you want to add a special character, you are allowed to add the underscore sign. This is the only thing that is allowed in the variable naming. You can even add the underscore sign at the beginning. So a variable name can start with underscore or with a letter, but it cannot start with a number. You cannot use the reserved words, as we already mentioned, like integer, and you cannot name a variable or use the same variable name twice, like int x, int x. It will give you a compilation error because here you are defining a new variable, naming it x, and you are telling the compiler to go to the memory and assign a location with the name x as an integer. Then you are telling the compiler to go again and assign the location with the name x and the type of integer, and there's already a variable named x. So this will give you a compilation error. You cannot use the same name more than once. Now the last thing that we need to mention is that you cannot leave a space or a blank in the variable name. Let's name it new variable. Now this will give you a compilation error because int new is the variable and the blank and the other word are something else. So the compiler is not recognizing them. If you want to leave a space, you can either use the underscore or you can use a naming invention called camel case, where you name the first letter of every word with a capital letter. So new variable name, like this. Or simply use the underscore. Here underscore, and here is another underscore. Now this is another methodology. You cannot use commas inside the variable name, as you already mentioned. You cannot use blanks and you cannot use reserved words. You cannot use special characters except for the underscore sign, and you cannot use the very same name for different variables for the same variable in the same scope. Now when we say scope, we mean these two curly braces. This is the scope of these variables. Now if I try to call x outside this scope, like here, it won't recognize it, but this is something that we will talk about later. So let's summarize. A variable name may contain underscore, numbers from 0 to 9, alphabets in capital and small letters. The first character of a variable must contain either an alphabet or an underscore sign. It cannot start with a number. Blanks and commas are not allowed. Variable name should not be reserved word. And plus the fact that special characters are not allowed except for the underscore. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about print function. Now look at this code. Let's discuss what's happening inside this code. First, we are calling the library. Then we are defining our main function as we usually do. Then we are defining an integer variable named x, and we are giving it a value of 10. This is a semicolon to indicate that this is the end of this line. We are calling the print function, and inside it we have written the variable value is x, and we ended the line with a semicolon. What is the expected output of this program? Now pause the video and try to guess the expected output. I'll give you 5 seconds. Hopefully you will pause the video and try to figure out the output without running the code. Now if your answer was this, the output on the display will be the variable of value is x, then you are right. This is a string literal, so it will print the string as it is. It won't print the value of 10, it won't replace x with 10 here. And this is what this lesson is about. Now, the print function flashes the variable inside the string. The print function can print a variable inside the string. It could be done by inserting something we call format specifier. Now the format specifier is basically something you add inside the string that indicates that you want to print something. The format specifier will be replaced by the value specified in subsequent additional arguments. Insert the format specifier to be replaced by the specified value after the additional arguments. If things are not yet clear, let's first talk about the format specifier syntax. Most common specifiers used for print function are %f, %c, and %d. %f inside the string indicates that you want to replace this with a floating value, while format specifier or %c means that you want to replace this with a character value. The last one is the most common one of these three, is the %d. It indicates that you want to replace this format specifier in the string with a decimal value. Usually, it follows this pattern. The variable value is, then you add the format specifier between the double quotation inside the text as is. Now, the new thing is that you must add a comma and add the variable name. What this print function or this line will do, it will replace the format specifier, which is %d, with the variable value of x. So it will print the variable value is 10. And this is called a format specifier. You need to memorize this word as we will mention it a lot. Now, let's see this in action. Now let's write as usual. Include the stdi o.header, void main void as usual, and try to write the code from scratch every time so that you are getting used to writing C codes. Now let's define a variable, give it a value of 10. So we defined an integer value, an integer variable. The name of the variable will be x, the value or the initial value will be 10. Now let's print if the variable, the x variable value is, here we need to add the format specifier. I added %d because integer is a decimal value. If it is a floating point value, we need to add f. If it is a character value, we need to add c. So add d here, then add the new thing, which is the comma, and the variable name, x. Now this line will print the x variable value is, it will replace this with 10, which is the value of this variable. Let's save our work. Let's call it 3 print variable. And let's try to run it. Here we have the compiler, GCC 3 print variable .c and a.exe. As you can see, the x variable value is, and the %d, which is the format specifier, was replaced with 10. That's it. This is how easy it is to print a variable within the printf function. Now let's talk about common mistakes. Most people write x here instead of writing the common value, which is or the format specifier, and when they compile, this is what they see. The x variable value is x. So we need to replace this with d. Now the format specifier will be replaced with the x value. Another thing that you can do is to print more than one variable in the same printf function. If you want to print y, you can add the value. Let's print it on a new line. So add %n, which is the escape character that we already introduced, and add the value of y is, add another format specifier, %d, and add another comma, then y. Now what will happen here is simple. It will replace the first format specifier with x and the second format specifier with y. Now if you have another variable, you can add another format specifier and it will be replaced with the third variable, and so on. So this string will be print as it is. The only thing that will be changed is the format specifier. The first one will be replaced with x, the second one will be replaced with y. Let's save and compile the code one more time. Now if you want to clear the CMD or the command window, simply write CLS or clear screen and will clear everything. Now let's compile it, GCC and the C file name, then run. As you can see, the x variable value is 10, which is this line. Then /n means that go to a new line. The value of y is, instead of %d, we will see the value of y, which is 15. As you can see, 10 and 15. Now, what I need from you to make sure that you did understand everything that we explained in this lesson is to write this very same code and make sure that you are looking to the same results on your screen. Make sure that you don't add the closing of double quotation here, because in this case it means that you are printing this. Now let's see what will happen if we did that. Let's clear our screen, run the file. As you can see, the x variable value is a very huge number and the value of y is a very huge number. Now this is the default value for decimal variables in this compiler. As you can see, now it did print x and y as a normal text. It didn't replace any of these things because we misplaced the double quotation. So you need to remove it from here, add it to the end of your text, make sure that you have the commas in their right place, and the variable names. That's it for this lesson. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about scanf or scanning a value from the user. Now what we covered so far is how to print a value on the console window. But what if we want to read a value from the user? This is where scanf is used. The scanf function is used to get value from a user and save it to a variable. It is a part of the stdio library, the library that we include at the beginning of our code. Now, the syntax for this function is simple. You just write scanf, then you open two parentheses. Now, first part is the format specifier. Here you must add a format specifier between two double quotation. Let's say that we want to read an integer value, so we will add %d between these two double quotation. Now the second part is adding a comma, then the add sign. After the add sign, we need to add the variable name. So in this case, let's say x. So we will write and x. Now this is an example. As you can see, here we defined a variable. We called it x, integer x, and then we use scanf with these two parts. The first part is the format specifier, then a comma, then the and sign, then the variable name. You need to make sure that you follow the very same structure like in this line. Scanf, %d, which is the format specifier between two double quotation, a comma, then the and sign and the variable name, then close the parentheses and add a semicolon. Scan function, again, is a part of the studio or standard input-output function. So there is no need to add any or include any other file. Now let's see this function in action. Now let's do the regular thing. Let's include the function that has the libraries for printf and scanf. Then let's add a main function. Now press enter here, press enter here. Change the language to C. Now let's define a new variable, int x. Let's give it an initial value of 0. Now print something for the user to inform him that we want him to enter a value. Enter your age. And let's change this with age. Now this will print this sentence on the console window, informing the user that we want him to enter his age. After that, we will use the scanf function. Now the first part is the double quotation, the comma, and the and sign in the second part. Now between these two double quotations, depending on the variable type, we must add a format specifier. Here it will be %d. Now if this is a character, it will be %c. If it is a float, it will be %f, as we already mentioned. So we'll add %d, and here we will add the and function, or the and sign, and the variable name, age. Now this will take anything that the user writes up to the point that he enters enter, which means that he finished entering the text, and will store it inside the variable called age. Now this line will read the input from the user. So let's add another line to print the age. Let's write printf your age is, and as we already mentioned in the previous lesson, to print a variable we must add a format specifier inside the two double quotation, then add a comma after the double quotation, and the variable as it is. Now to make sure that we see all of these each in one line or in a new line, we need to add a /n, and here another /n at the end of each line. Now once we are done, click save, and let's call it scan variable. Now let's go to file as usual, open, then cmd. Now in here write gcc.c. We are done. Let's zoom in to see. Now write a.exe, which is the executable for our C file after compiling. So as you can see, enter your age. Let's compare it to what we have here. This is the first printf function, enter your age. Now after this line, as you can see, this is a blinking cursor for the scanf. So I will write 32, then I'll press enter. Once I press enter, it will execute the third line. It will write your age is, and will put the age value here. So press enter. So your age is 32. That's it. This is how easy it is to scan a value from the user, store it in a variable, and print it in a new line using printf. Now if you have any questions about this, please ask in the Q&A board. I'll be more than happy to help, but as you can see, it's a very simple thing to do. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about operators. Now operators are a very important thing when you are programming, because you'll need them when you are doing calculations, when you are checking if a condition is true or not, or when you are inside a loop and you want to increase a value. We have different types of operators, and in this section we will explain them one by one with an example, and we will try to make sure that you understand each and every one of them with a use case and a scenario. The first one is the arithmetic operation. Now the arithmetic operators, there are two types of them, the uni and pi, and we will explain them in a minute. There is also the bitwise operators, which are used to play with bits level. There are assignment operators, relational operators, logical operators, and other operators like the size of operator, the ternary operator, the address operator, the difference operator, and the subscriptor operator. These are only the names, so let's get started with the arithmetic operators. Now this is a table that has all of the arithmetic operators. Most of them are straightforward. First thing that we need to explain is the word pi. Now there is the uni and the pi. The pi is basically operators that takes two operands, so they must have two operands to be called pi. An example of these is the summation, which is basically this sign, and the subtraction, which is basically this sign. Multiplication, which is the asterisk sign, division, which is the slash sign, modulus, which is the percentage sign. Now let's talk about each of them. The summation is basically used to sum two operands. This is the first operand and this is the second operand. Now here we have x equals 10 and y equals 5. So x plus y is basically a summation operation because we are using the arithmetic operator, the plus. So the result will be stored, of this sum will be stored inside this variable. So x plus y, 10 plus 15. So 10 plus 5, it will be 15. And this is the result. So some variable will include the value of the summation, which is x plus y. Now regarding the subtraction, as you can see, the same example as above, two operands, x minus y, which is 10 minus 5. The final result is 5, so 5 will be stored inside the sub, as you can see here. Sub equals 10. Now in this case, sub is wrong, because 10 minus 5 is only 5. Now let's move on to the multiplication. X multiplied by y. X here is 10. Y here is 5. Now when you multiply 10 by 5, it will be 50. So here we have this answer, 50. So the variable called multiply, it will be 50, which is an integer. Now we also have the division, x, which is 10 divided by 5, which is basically an integer. 10 divided by 5 equals 2. So the result will be stored inside the division variable, which is basically 2. Now we have the mod sign. The mod sign is basically a sign that gives you the reminder of a division. So if you are dividing x mod y, now I need to concentrate on this one. When we say x mod y, first you need to make sure that you have x divided by y. So if x is 10 divided by y, which is 5, 10 divided by 5 equals 2. There is no reminder in this division. So the result, or the final result for the percentage, which is the reminder, will be 0. Now, if y is divided by x, now this is a reminder sign. Again, you need to do it first as a division, then you take the remainder of that division as the result of the mod. So y divided by x, y here is 5, divided by x, which is 10. Now, when we divide 5 by 10, this is called a division. So 5 by 10 here, 5, 1, 5, 2. So the final result will be 1 divided by 2, which is basically 0.05. So in this case, the final result will be 0, and the remainder of this will be 5. So the division value will be 0, and the remainder value will be 5. That's why you see the result here as it is here. As you can see, mod equals 5. Now to make things more clear, let's try this example. 10 mod 3. 10 divided by 3 equals 3. Now if you multiply 3 by 3, it will equal 10. So 10 minus 9, it will equal 9, sorry. 10 minus 9 equals 1, and this will be the result of the remainder. Let's try this again with this. Now 9 divided by 1 equals 9. There is no fractions and no remainder, so the mod will equal 0, just like in this example at the beginning here. Now let's try this one. This is the mod, not the division. So 17 divided by 9. 17 divided by 9, it will equal 1. So here, write 1. Now 1 multiplied by 9 equals 9. So 17 minus 9, the remainder will be 8. This is the remainder. And this is the division. And as you can see here, mod equals 8. Now what you need to understand is that the division gives you a value without a fraction. So if there is a fraction, it won't be printed when you are using the division sign. It will just print the value and it will leave any fraction. So in this case, if you need the fractions or if you need the remainder, you must use the remainder sign. Now let's try this in action and let's print the values to make sure that everything we said here is correct. Now let's start by including the stdio.txt library, void main void as usual. Now let's change the language to C. And I need you to do this from scratch every single time. Now let's store the value 5 arithmetic operator. Now let's define two values, int x equal 10, int y equal 5. Now let's do some operations. Int sum equals x plus y. Let's print sum. Sum equal %d, and let's add /n. Here we can add sum to see the results. Now I'll do all of the operations. So let's do the division as well. The multiplication, the mod. All of these are pi operators because they take two operands, as you can see here. This is the second operand and this is the first operand. Now to print the results, write printf equals and %d /n, and here add div. Now you can copy this line and paste it here. Copy this line and paste it here with some modification. The mod also, just to save some time. Now here it is. This will sum these two operands, this will divide them, this will multiply them, and this will give us the mod. Now let's write the result here. Now first the summation result will be 15. The division result will be 2. The multiplication result will be 50. And the mod result will be 0 because we already know that x divided by y, 10 divided by 5 equals 2, and we don't have any fractions as we already mentioned, so the mod will be, or the remainder will be 0. Let's save the work and run the code again. Now in here, let's go GCC and let's write the file name 5. Now here is the file name, as you can see, GCC. To compile it, now we have the executable. So write a.exe, and here we have the results. 15, 2 for the division, 50 for the multiplication, 0 for the remainder. Now to make things look more like interesting, let's say, let's move this. Now let's play with the printf function. Let's change this with %d plus %d equals the result. Now, what I need to do here is to add the x value, the y value, and the result. So to replace this with x, first we need to add x here, as we already mentioned in the printf lesson. To replace this with y, we need to replace y next. And to replace this with the summation, we need to place the summation. So this will print x plus y equals the result. X will be replaced with the value of x, y will be replaced with the value of y, this will be replaced with the sum value. The first variable, second variable, third variable, and this was explained in the printing variables lesson. Let's do the same for all of these. Now we just need to change the sign here. This will be the division, this will be the asterisk sign, and this will be the remainder sign or the percentage sign. Now we don't want 2/n. Set. Now let's go back, compile the code one more time. Clear the screen using CLS and run the compiling command and then run the file. Okay, now as you can see here, we have the first one written in the right order, the second and third one, and the fourth one. There are problems with these because, as you can see here, we didn't add the x and y before the div. As we already mentioned, each of these format specifiers will be replaced with the associated variable. So save it one more time. Clear. Here it is. 10 plus 5 equals 15. 10 divided by 5 equals 2. 10 multiplied by 5 equals 50. 10. And the last one, okay. We have a missing D here. Now, this is a very nice piece of information. As you can see here, we have %d, and we have %d, and we have %d. Yet, it wasn't printed correctly. That's because we have a percentage here inside our string. Now, this percentage will be treated differently because we usually use it to add a format specifier. So if you want to print a percentage sign in our final printf window, we need to add double percentage, like that. Now, once you add them like that, the printf function will understand that you want to show the percentage sign once on the screen. And this is a very good tip. Now, going back, let's compile the codes. a.exe. Now, as you can see, it was printed correctly. Otherwise, it won't be printed correctly. So you need to take a note that you must add double percentage sign to print it on your console window. So 10 reminder 5 equals 0. And these are the main arithmetic operators. That's it for this lesson. If you have any questions regarding anything, I'm here to help. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about the Unary operators. Now in the previous lesson we covered the by operators, and here we are talking about arithmetic operators. Now the Unary operators takes only one operand, so there is no need for two operands like x and y. One variable will do the job. Now in our case we have two types of operands. Now, we have the increment operator and the decrement operator. And we have them separated because using the increment and decrement with one variable without the equal sign is something, and using them with an equal sign is another thing. So, the increment means two plus signs. The decrement means two minus signs. Now, this means add one to the variable, and this means subtract 1 from the variable. Now, in this case, we call this a postfix, and we call this a prefix. This is pre because we are adding the two plus signs before the variable. This is a postfix because we are adding the two plus sign after the variable. Now, if we executed both of these sentences, taking into consideration that the variable x equals 10, this and this will add 1 to the variable, so x will equal 11. And in here, x will also equal 11, whether it's postfix or prefix. Now, when it comes to the decrement, it's basically the same thing. We have a postfix and prefix. This is the postfix, and this is the prefix. When we are calling it, knowing that the x value equals 10, it will result in this. X will equal 9, because the decrement will subtract 1 from the variable. And in this case, it will also equal 9, whether it's postfix or prefix. Now, up till this point, there are no problems. Everything is clear, everything is easy. This will increase the variable value by 1, and this will decrease the variable value by 1. Now, the problem comes when we have an equal sign. This means that we need to execute this, store the result inside the variable. And in this case, the postfix and prefix that we mentioned up here has a different meaning. So let's start with the first one. This one is a postfix. This is basically a sentence in which we say that the compiler, or in which we tell the compiler to assign x to y. So it will first store x inside y. Then it will increment x. And the order of operations is very important here. The postfix is basically doing the assigning using the equal sign, x will be assigned to y. Then it does the increment that we did here. So the final result will be x will equal 11. It will be increased by 1, but the value of y will equal 10, because when we first assigned x to y, x value was 10, as you can see here. So 10 will be stored inside y, and this is the first part. The second part is basically incrementing x, so x plus plus, so x will become 11. Now this is in the postfix. The prefix, however, will do something different. It will first increment x, as you can see. This is the first step. And the second step, it will store the result from incrementing x and assign it to y. So incrementing x will result in 11. So x will equal 11. Then these 11, or the result as 11, will be stored inside y. So y will also equal 11. And you can see the difference between these results and these results. So what I need you to understand is, in case you saw a postfix, this means that you need to assign the variables first, then increment. But if you saw a prefix, it means that you first need to increment, then you need to assign the value. Same thing goes here. Here we have a postfix, so it will assign the value of x to y, so y will equal 10, then it will decrement x by 1, so x will equal 9. Same thing here, it will first decrement, so x will equal 9, then it will store the result inside y, so y will equal 9. You can see the difference between these 4 lines and these 4 lines. These 4 were very easy. It's simply incrementing or decrementing, whether it's postfix or prefix, while in this case, it's different. Now, if it is postfix, it will assign, then increment. If it is prefix, it will increment, then assign. And you need to keep that in mind and take a note about it. Now, as usual, to make things more clear, let's take a practical example. Now here you need to hash include the library, then write the main function. Change the language to C, and you are good to go. Let's call it uni. Now in here, let's define x as, and give it a value of 10. And let's define y without giving it a value. Now x plus plus and plus plus x minus minus, minus minus x. These are the first 4 that we will test out. Now what I need to mention here is, to make sure that we will get the right results, we need to reassign x as 10 after each operation, to make sure that we are changing the value of x when it is 10, because otherwise it will keep changing the value of x with the new value. So here x will be 11, and this will be 12, this will be 11, this will be 10. We need to do these operations on the original value of x, as in the example. Now let's print. I will write the same thing, x plus value equal %d, and let's add x. Now let's add /n here as a new line. Let's copy this, paste it here, paste it here, and paste it here. Now we will change this with x minus minus. This will be minus minus x, and this will be plus plus x. Now let's talk about what will happen when we run this code. First, in this case, it will increase x by 1, x plus plus. So it will print here 11. Now x will go back to 10, and will also increase it by 1, so it will print 11 one more time. X will go back to 10, it will decrease it by 1, so x here will equal 9. It will go back to 10, it will increase it by 1, then x will be 9 as well. So 11, 11, 9, 9. Now let's try running this code. GCC 6 Arithmetic Operator uni.c a.exe. As you can see, x plus plus and plus plus x have the same result, 11, 11. X minus minus and minus minus x have the same result, which is 9. Now let's add a multi-line comment to this area and do the other operations. We mentioned that we have y equals plus plus x plus plus first, and we need to print it. Now we need to print the values of x and y. So x value equals this, and after the slash n, y value equals this. So x and y. Let's add slash n here as well and see where things will go. And another slash n here. Now this will print this, then it will go to a new line. It will print this to a new line with the value of x. It will go to a new line to print this with the value of y. That's it. Now we need to make sure that x value equals 10 each time we run this command. Now let's copy this, paste it as before 4 times. Now this will be plus plus x, which is the prefix. This is the postfix. This will be x minus minus, and this will be minus minus x. So let's copy this, place it here, copy this, place it here, and copy this, place it here. These are just the same Unary operators that we explained earlier, and we are just testing them out. Now if you want to separate them, you can add this and slash n to make sure that they are separated when they are printed. Now this will make the value of x equals 10 each time before running the command to make sure that we are starting with the same initial value. Now going back here, let's compile the code, clean the screen, and run the code. As you can see, y equals x plus plus. Now we already know that the value of x is 10, and the first thing that this did is to assign y to x. So y value will equal 10, as you can see in here. And the second step is incrementing, so x value will equal 11. Let's go here. This is a prefix, so it will first increment x, so x value will be 11. Then it will add the 11 to y, so y value will be 11, just as we explained. Now when it comes to these two, x minus minus, this is a postfix, so it will first assign the value of x to y, so y will equal 10. Then it will decrement x by 1, so x will equal 9. Going here, this is a prefix, so it will first decrement x. So x value will equal 9, then it will store the 9 inside y, so y will equal 9. As you can see, this is a live demonstration of the equations that we introduced in this lesson. Now, if you have any issue with any of these, I'll be more than happy to explain them in more details to help you understand. These are very important operators, they are widely used, and you need to understand them well. If you are using the Unary operator without assigning, using an equal sign, the postfix will be treated just like the prefix. There will be no difference. But if you are dealing with them with the equal sign, the postfix is different than the prefix. The postfix will first assign the operators, then increment, while the prefix will first increment, then assign the operators. That's it for this lesson. If you have any questions, please ask in the Q&A board. I'll be more than happy to help. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about the bitwise operators. Now, the bitwise operators are used to manipulate bits inside C language. Now, let's start with the AND, OR, XOR, and NOT. As you can see from these tables, when you see the AND sign, this means that whenever there is 0, the result will be 0. So if we have two operands, A and B equals Y. 0 and 0 will equal 0. Since here we have a 0, it will equal 0 as well. And since here we have a 0, it will equal 0 as well. The only time that the result will be 1 is when both of the operands is 1. So 1 and 1 equals 1. When it comes to the OR table, now let's talk about the OR. Now when it comes to the OR, you'll usually see this sign between the two operands, A and B. Now for the AND, you will see the AND sign, so it will be A and B. In case of OR, whenever you see 1, the final result will be 1. So here we have a 1 and final result will be 1. Here we have 1 and the final result will be 1. Here we have two 1s, this one and this one, and the final result will be 1 as well. Now the only case that the result will be 0 if there are no 1s at all, neither A or B are 1, so the final result will be 0, which is basically the opposite of the AND, almost opposite. Okay, now for the XOR, as you can see in here, the XOR is basically this sign. So A XOR B. In this case, if the two operands are similar, the result will be 0, as you can see in here and in here. If they are different, the result will be 1. Now, the last one, which is the easiest one, it's the NOT sign. The NOT sign is a Unary operator. These are by operator because they take two operands, as we already mentioned, and this is a Unary operator, so you'll see not A. So not means the inverse of A. So if it is 0, it will become 1. If it is 1, it will become 0. That's it. Now, let's see them in action. Let's say that we have two values, x and y. X here equals 1, 0, 1, 0. Y is 0, 1, 0, 1. And these are called binary values. And we can talk about binaries at the end of this course. Now, these two are the two values that we will do these operators on. We will do AND, OR, NOT, and XOR. Now, when we are doing the AND, X and Y, the final result will look like this. We already mentioned that the AND sign means if there is 0, then the final result will be 0. So when we are talking about the AND, 0 and 1, we can do this to see the values. 0 and 1 will equal 0. 1 and 0 will equal 0. 0 and 1 will equal 0. 1 and 0 will equal 0. So the final result here will be 0, as we saw in the truth table. Now, regarding the OR, we already mentioned that this is the OR sign. Now, if there is 1, then the final result will be 1. So 0 and 1, 1. 1 and 0, 1. 0 and 1, 1. 1 and 0 will also equal 1. So it will be either a binary value of 1 for ones, or we can convert it to a decimal value using the calculator. Now you can change the calculator to programmer, and you can enter the binary value 1 1 1 1, and as you can see the decimal value is 15. So this equals 15. Now the not sign is straightforward. Not x means this is the sign, not. So not x means the inverse of x. So it will be 1 0 1 0, since x equals 0 1 0 1. And we can use the calculator to convert the value. We can write 1 0 1 0, which is the original value. It equals 10 in decimal. So let's write the new value. Okay, it was written incorrectly. Now let's add 0 1 0 1. As you can see, it equals 5 in decimal. So this will be 5 in decimal. I need you to memorize these values because we will do this in a practical way in a few seconds, and we need to know the results. Now, x or y, we already mentioned that if they are both identical, then the value will be 0. If they are different, the value will be 1. Since all of these are different, 0 1 1 0 0 1 1 0, then the final result will be the same as here, 1 1 1 1, which equals 15 in decimal. Now we can do a lesson about numbering systems, but this is like a prerequisite for this course. That's it for the bitwise operators. Now, to make things more clear, we need to take a quick example. So let's move on. Now, let's start by writing our include. Void, as usual, main void. Change the language to C. And in here, we need to define the values. So int x will equal the binary value of 1010. If you wrote it like this, it will treat it as a decimal value. So to make the compiler understand that it is a binary value, you need to write 0b. 0b means binary. This is the prefix for the binary. Now we need to add y as well. So 0b 0101. Now once you are done, we need to start defining new variables. Int and operator equals x and y. Int or operator equals x or y. Int XOR operator equals x the power of sign y in not operator equals not sin x. Now let's print this out using a printf function. So I will write them as they are, equals %d, and let's add the result here. Add /n here, copy this line, now paste it here, and paste it here. Change this with this, not operator. Change the XOR operator and the equation. Change the OR operator with the equation. Now let's save it. Bitwise Operators. And let's try to run this. Now let's zoom in. GCC C a.exe. Now as you can see here, we have 0, 15, 15, which is something we expected, and here we have minus 11. Now let's talk about the minus 11 here. Now at this level, we won't go into the depth of the minus values, but let me show you on the calculator what will happen. Now the value is 10, 10. Once you choose the bitwise not operator, you will see that the decimal result will be minus 11. And this is because the 1010 are not treated on their own. The binary operation not is done on all the bytes that are left. So yes, you did write 1010, but the rest of the bits were written as zeros. And in this case, the not will reverse them to 1. Now in the coming lessons, we will cover the negative values and how to print them and how to interpret them inside your console window. But at this point, what you need to understand is that when we did the not function, we did it only on 4 bits. We didn't take into consideration how many bits or bytes the compiler will assign for the not operator. So if it has assigned 1 byte, then the final result will be 10, 10, 1, 1, 1, 1. Because 1 byte means 8 bits, and the original value is 0101. These are only 4 bits. There is also 4 zeros that are hidden here. So we'll convert them to 1. Now other compilers assign 4 bytes for an integer. And in this case, we will have 3 more bytes of 1s. That's why this is an advanced topic, and we will cover it in the coming lessons. Now, if you reach this point and you are able to apply the AND or XOR and learned how to apply the NOT operator, then you are good to go. Thanks for watching this lesson. Next, we will talk about more bitwise operators that are advanced and used in bit manipulation. But that's it for this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about 2 more bitwise operators, the right shift and left shift operators. Now, the right shift operator is basically these 2 signs, and the left shift operator is these 2 signs. Now, X right shift by 1 or Y left shift by 1. Now when we say right shift or left shift, we mean this in a bitwise level. So let's say that we have this registry. And let's assume that the width is only 1 byte, which equals 8 bits. Sorry. Now, these are our 8 bits in memory. 1, 2, 3, 4. 1, 2, 3, 4. And let's assume that this is x. And let's make x equal 10. Now 10 in binary will be stored inside this. This is an 8-bit variable that will take the value 10. Now 10 is in decimal. Now in binary, 10 equals 1, 0, sorry, 0, 1, 0, 1. And the rest will be zeros. This is the number in binary. And the associated number is 10 in decimal. So let's store the value of 0, 1, 0, 1, 0, 0, 0, 0. Now when we say x right shift by 1, it means that we need to shift all of these 8 bits to the right by 1. So this will be moved here, and this will be moved in this place, this will be moved in this place, and so on. Now we will have an empty bit here, and it will take a default value of 0. So the final result will be 1, 0, 1, 0, 0, 0, 0, 0. This is the right shift. We did shift all of these bits to the right by 1, so we lost this 0. This 0 was written here, and basically there is nothing here, and it will be gone. So the first bit here will be the 1, because we right shifted it by 1, and the third bit will be the second one, the fourth will be the third, and so on. Now if we executed right shift by 2, means that we are shifting each of these bits 2 digits to the right. So this 0 will be moved twice, this one will be moved twice. So if we move this 0 twice, it will be out. If we move this 0 twice, this 1 twice, it will move to here. This is 1, and then to here, this is the other one. So this one will go away, and this one will go away as well. So we'll start with 0, 1, and the rest of these bits will be zeros. This is when we right shift by 2. This is when we right shift by 1. Now what about left shifting? Now when we do the left shift, it's basically the same principle. Let's copy this area, and let's paste it anywhere, like here. Let's draw this more time with the same value. Let's add 0, 1, 0, 1, 0, 0, 0, 0. Now what we need to do is to left shift. Let's say that this is called y. We need to left shift y by 1. So if we left shifted this by 1, this will be moved here, this will be moved here, and so on. And we will end up with this place as an empty place. So let's add 0 in the empty place. And once we are done, we will left shift all of these. So it will be 0, 1, 0, 1, 0, 0, 0. So we lost this 0. Now let's talk about moving it twice to the left. Now here we moved it once, and we have this block moved once to the left. So that's why we have it here. Now if we want to move it twice, we will add 0, 0. Then we will add this block 0, 1, 0, 1, 0, 0. As you can see, this is the block that we are focusing on. Now this value will be moved twice, so it will be here. This value will be moved twice from here to here and from here to here. And this is why you can find it here. So this is the meaning of right shift and left shift. And this is how it's done in bits level. Now we will do it in C using decimal values. Now to do it, first we need to understand how to treat decimal values and how to deal with them, and we will have a separated lesson for that as we already mentioned, but for now we will use the calculator. Now let's take the same example. Include stdio.text and in here void main void, change the language to C, and inside here let's add two variables. Now let's define x as an 8-bit binary number, so add 0b 0000 and add 1010. Let's define y as well, 0b, and 0b is the prefix of a binary number. If you wrote the number without the 0b, it will be considered as decimal, which is the default numbering system inside C. So add 0b 0000 0101, and this is y. Now let's use the right shift. So integer right shift equals the value of x right shifted by 1. And for left shift, the value of y left shifted by 1. Now let's print the values. Print f let's add the equation equals %d /n, and here add right shift. Now copy the same line, paste it here, and change the equation with the y left shift and print left shift. Now let's call this bitwise shift. Now let's explain what will happen here. Now this will be right shifted by 1, so the final result will look something like this: 0b 000 101, and there will be a +0 here. So we will have 5 zeros and 101 because we right shifted this, so this will move to the right one and will disappear. This will be the first bit, as we already explained, and all of these bits will be right shifted by 1, so we'll have this as an empty place in the 8-bit value and will be replaced with 0. Now this one will be left shifted, so the 1 will move to the left by 1, so we'll have an empty place here. So in this case we will add 0b 0000 1010. A 0 will be added here because all of these bits will be left shifted by 1, so the final value will be this. Now let's convert it to decimal using the calculator. Here it is. Let's add the decimal value, or the binary value, sorry, of 00000101. Now 101 here equals 5 in decimal, so 5. Now let's clean. Let's add 1010 equals 10 in decimal. So this will be 10. Now this is after doing the right shift and doing the left shift. Now let's save the work and let's open up the CMD to see if this matches our calculations. So write gcc.c. Now it shows us that there is a problem. Here we forgot to add the hash sign. So CLS. Now a.exe, as you can see, x right shifted by 1 equals 5, which is this value. Y left shifted by 1 equals 10, which is this value. And this is how you deal with the right shift and left shift operators. Again, you can right shift or left shift by 1, 2, 3, 4, 5, or any number of locations you want. The number here indicates the number of shifts to the right or to the left. And the signs show you the direction. This is to the right, this is to the left. Now, if you added only one sign, it won't be a shift or a bitwise operator. It will be a greater than or less than operator. So make sure that you don't misuse this. Again, it can be executed easily using this command or this command. And the thing that I wanted to mention is that in C, when you are initializing a variable, if you added 0b, it means that you have to add 8 bits after that to indicate that this is a binary number. 0b is for binary. Now we also have 0x for hexadecimal, but this is something we will talk about in the numbering systems lesson. And if you left it to the default, if you initialize the variable m equals 5, 5 will be the decimal value because it doesn't have any prefix, which is the default value in C and the most used value in C. Now, I just introduced the binary values because we need them for the bitwise operator, right shift and left shift. Thanks for watching this lesson. If you have any questions or if anything isn't clear, please ask in the Q&A board. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to discuss assignment operators. Assignment operators are used to assign different values using different operators. Some of the operators we already talked in previous types of operators. The first one is the assign operator. It's a very straightforward one. It's basically the equal sign. And here we are assigning the value of 20 to the variable x. Here we have and assign, the plus equal sign. This can be interpreted to x equals x plus 3. What this will do is add 3 to x value and assign the final result to x. So in this case, if x equals 10, which is the previous value of x, 10 plus 3 equals 13, and these 13 will be stored inside x as the new value. We usually use the plus equal 3 to short this equation into these onto this shape. Now same thing goes for all of these equations. X minus equal 4 is basically x equals x minus 4. And if x is 10, then 10 minus 4 is 6. So the value of 6, which is the result of this, will be stored inside x. So x value will be updated and become 6. Now going here, x equals x multiplied by 5. X equal, or the original value of x is 10. 10 multiplied by 5 equals 50. So x will equal 50. This will be the new value of x. if we went down here to the last one, x equals x divided by 2. So 10 divided by 2 is 5, and 5 will be stored inside x. So the new value of x will be 5. This is the short form of this equation. This is the short form of this equation, and this is the short form of this equation. Now, we also have the same thing for the bitwise operators and or not, and we have it for the mod or the percentage sign operator. Now x and equal 1, it means x equals x and 1. And since we are dealing, when we are using AND or XOR, we are dealing with x as a binary number, it will equal 0, 1, 0, 1. And we want to AND 1 with this, it will be 1 here. So the final result will be 1, 1, 0, 1. So 3 plus 10 equals 13. So the final result will be 13. Now, the same thing goes for the OR and XOR. X equals X or 15. X equals X, the XOR sign 2. You need to convert 15 to the binary form. So 0, 1, 0, 1, and 15 equals 1, 1, 1, 1. This is X, the original value, which is 10, and this is 15. Now the final value, you have to OR them, or 0 and 1 equals 1, 1, 1, 1. So the final value will be 15 as well. So X will equal 15. And we already mentioned how to do this in the Bitwise Operators lesson. Now, the XOR is the same case. You need to add the value of X, which is the original value, equals 10, and 2 is 0, 1, 0, 0. Now, we already mentioned that if they are identical, the result will be 0. And here the result will be 0, here the result will be 0, here it will be 1. So the final result for X will be 8. So X equals 8 as a final result. This is the result of the XOR operation. You can use the calculator to make sure of these numbers, or you can watch the lesson that we will add to the end of this course that is called Numbering Systems, in case if you are interested to learn how to convert binary into decimal without using the calculator. Now, the last equation here is X equals X mod or percentage 4. Now, we already know that X value is 10, and we mentioned that you need to divide it by 4. So 10 divided by 4 equals 2. Now, 2 multiplied by 4 equals 8. 10 minus 8, 10 which is the original value, minus 8 which is the result of the multiplication, will equal the remainder, which is 2. So the answer here will be 2. X will equal 2. And I just showed you how to calculate it. First, you need to turn this into a normal division. 10 divided by 4, it will equal 2 without fractions. When using division, there are no fractions. Now, to know the remainder, we need to multiply the result without fraction by the division factor, which is 4. The result will be 8. And then we subtract the original value, which is 10 for X, minus 8, which is this value. The result will be the remainder, which is 2. X equals 2. Now, the last two assignment operators are the shift right and shift left. Now, when we write it like that, X shift right by 1, we are applying right shift to X by 1, and assigning the value to x. So it's like writing x equals x right shift by 1. Same thing here, x equals x left shift by 1 without using the equal sign. And this is a very important thing to know, as you can see. So in this lesson, we learned the assign, the add and assign, plus equal, minus equal, multiply, divide, and, or, XOR, and the modulus. We also learned the right shift and left shift. Now, let's do a quick practical implementation for these values to see the result. Now, first we need to include the library, as usual. Then void main void. Change the language to C. And let's define x equals 10. Now let's call this assignment operators. Now, we already mentioned that we need to try all of the assignment operators that we just mentioned. The first one is x equals 10. We just tried it, the assign. Then we have x plus equal 5, x minus equal 3, x multiplication equal 5, x division equal 2, and we have the and, x and equal, let's say 1, x or equal 1, x or equal 1, and we also have x right shift by 1, x left shift by 1, and we have the mod sign, x mod equal 2. Now, we already mentioned that we must reinitialize x after each of these operations. This is something you must do to make sure that you are getting the right results. So let's do this here as well. Okay, we are done. Now, let's remove this from here and print the values. So printf let's add %d and x. Now here I will add the equation, but let's first copy this. I'm just doing this so that we can see the final results for each of these operations. That's it. Now we just need to copy these equations inside the double quotations. Okay, we are done. That's it. We just need to add this equation here as well, plus equal. Now let's try running this program. Now GCC, let's zoom in. 9 assign operator.c, a.exe, and here we have the results. Now 10 plus equal 5 equals 15. 10 minus equal 3 equals 7. 10 multiplied by 5 equals 50. 10 divided by 2 equals 5. X equal 2. I think this is the percentage sign. Okay, now to get it right, we already mentioned that you need to write it twice. Let's clear the screen, compile again, and run. Now x mod 2 equals 0. Since it's 10 divided by 2, there are no remainder. Now x and equal 1 equals 0. X or equal 1 equals 11. You can check it out yourself. X or 1 equals 11. X right shifted by 1 equals 10. And x left shifted by 1 equals 10. Now, all of the results are correct except for the last two, the right shift and left shift operators. Now, in some compilers, x shift left by 1 and right shift by 1 are not recognized unless you add the assignment operator, which is the equal sign. So to fix this, you need to go back to your code and write x equal and x equal. Now this will solve the issue in the GCC compiler. Other compilers will execute it as it is and show you the right result. Now let's compile again, see again. Now as you can see in here, x shift left to the right was 10 in both cases, which is the wrong value. Now here, x right shifted and left shifted, here it equals 5, here it equals 20, which is the right value since we added the assignment operator. Now, these are all of the assignment operators that you need to know. If you have any question about any of them or you failed to implement any of them, we are here to help. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about rational operators and true and false in C. Now, in C, any number that is not equal to 0 is considered a true value. 5 is true, minus 12 is true, 4000 is true. As long as the value is not 0, then it will be treated as true. Regarding false, if the number equivalent to 0, then it will be treated as false. But you need to know that if there is a statement in C that returns true, the compiler is free to choose the value of the true with the rule that it must be any number except 0. This is a good piece of information that you must keep in mind when dealing with relational operators and logical operators. Now, relational operators are basically operators that check equality or not equality or more than or equal, less than or equal, and these things. They are used in if statements or conditional statements that we will cover later. So relational operators checks the relationship between two values by determining whether it's true or false. Now, if x, okay, let's go back. If x equals 10 and y equals 5, like in this statement, this is a question. Checks if x equals y. This statement will return either true or false. Now, since x and y are not equal, it will return false. And we already mentioned that false equals 0. Now, if we went to not equal, this is a sign. Now, this will check not equality. So if x is not equal to y, it will return true. And since x is 10, y is 5, then this will return true. The third one is a statement that will check a more than. So it will check if x is more than y. And x here is 10. It's more than y, which is 5. So this will return true as well. This will check more than or equal. So if x is more than or equal, it will return true, and it is more than y, so this will also check as true. Here it will check if x is less than y, which is not true, so it will be false. This will check if x is less than or equal y, and this is not true, so it will check as false. You need to take a note. If you want to test and print a false value, it will print 0. However, if you test to print true value, the value is chosen by the compiler. Frequently, it is either 1 or 255. We will check these in a minute once we reach the practical section of this lesson. Now, let's move on to the logical operators. The ones that we covered here are called rational operators or relational operators. Here, we have the logical operators. Now, the logical operators are used in applying logical operations between two values, in which each are considered either true, which is not 0, or false, which is 0. So, we have the logical AND, as you can see here. The logical AND is written by writing two ANDs. The logical OR is written by writing two OR signs. Now, the logical NOT in here, x equals not 4. Since 4 is true, because it doesn't equal 0, then not true equals false. Then x equals 0. Now, to test these out, let's explain the logical AND and OR before moving to the practical section. Now here we have 3, which is true. We have 0, which is false. And we know that if there is true, which is 1, and false, which is 0, in the AND operator, then the result will be 0 from the truth table that we discussed earlier. Now here, 0 means 0, which is false. 3 means true, which is 1. And 1 and 0, when it comes to the OR function, it will give us 1. So it will be either 1 or 255, which interprets as true. In this case, 4 is true. And not true equals false, which equals 0. These are the logical operators, and the ones before them were the relational operators. Now, let's see how we can implement them inside our compiler. Let's first include the library and write void main void. Now in here, change the language to C, and let's start writing the lines. I will print them directly inside the printf function. So here we will deal with each of them. So let's say that we want to start with the equal, x equal y. Let's define x and y as the two variables. Now x equal y will result in will equal %d, and we will add the result in here. So we will add x equal y. Now you can either do this, or you can simply cut this, create a new variable here, let's call it m, and add the value inside M, then print M here. But to reduce the number of lines inside our code, I will use this instead and save one line. That's it. Now save. Let's call it Logic Relational Operator. Now let's copy this line, paste it here. We need 6 lines for the 6 relational operators, and we need 3 lines for the logical operators. So this will be X and here and as well. This will be or, and this will be not X. So it will be the same here, not X. Now here it will be equal, not equal. It will be greater than or equal, less than or equal, same here, greater than. I'm writing the same things that we just saw on the table, just to see how the result will print. So add /n here. Make sure that each of these lines will be printed separately in a new line. Now that's it. Let's see if it will print out or not, and we can fix any issue when we have any. Now GCC in logic rate operation.c. Now a.exe. As you can see, here we have the true and false sentences. Now let's check them out. X equal y, so they are not equal, it will be false, which is 0. X not equal y, it will be true, which is 1. X is greater than y, true, 10 is greater than 5, so it will be 1. S is greater or equal than y, that is also true, it will equal 1. X is less than y, it's false, so 0. X is less than or equal y, it's false, so 0 again. X and y. Now we already mentioned that and y will ask if x is true and y is true. Now x equals 10, which is true. Y equals 5, which is true. None of them equals 0. So true and true will equal true. Now regarding the OR operation, x equals 10 and y equals 5. Now we have an error here. It's printing 0 because we haven't changed this in here. So we need to change it, save the code again, go back, clear, compile, then run, and here it is. True or true equals true. Now not x, since x equals 10, which is true, not true equals false. And these, the first 6 here, are the relational operators, and the last 3 are the logical operators. That's it. We are done with the operators in C. If you have any question about any of these operators, I'll be more than happy to help answer all of your concerns and questions. Just ask. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about conditional statements in C. Conditional statements executes operations under specific conditions. There are 2 main types of conditional statements in C: the if statement and the switch statement. The one that we will start with today is the if statement. Now, If statement is basically a type of conditional statements that you can use to check if a condition is true or not, and depending on whether this condition is true or not, you can execute a specific piece of code. Now, let's talk about the syntax. Always make sure that you have the syntax right, then you start the coding process. We will talk in this lesson about the first case, which is only if condition without else if or else. Now, the syntax is as follows. You will write if and you will write two parentheses. Now, between the two parentheses, you will write your condition, like x is greater than y, for example. Then you will add two curly braces. Between these two curly braces, you will write your code or the action that you want to execute. So if the condition is true, then execute this action. Otherwise, this action won't be executed. Now, to make things more clear, let's see this in action. Now, let's include our main file as usual. And let's add the main function. Now in here, you can easily write anything. Let's initialize a new variable and give it an initial value of 50. Change the language to C. Now we will use if statement. This is the syntax. If, two parentheses, and two curly braces. Now press enter here as usual and between the two curly braces. Now this is where you will write your code or the action. And here you will write the condition. Now we will write a logical or relational condition if x greater than or equal 50. So this is the condition, and we know that it is true because x equals 50. Now we will print a statement. X is greater than or equal 50. That's it. If this condition is true, it will execute this line. Otherwise, it won't execute it. Now let's save the code. And let's compile it. Now let's zoom in, gcc.c. Now a.exe. As you can see, the action was executed because the condition is true. Now, if we change the condition to make it false, let's make it x less than 50. Now, you can go back here. You can compile the code again and run the a.exe. As you can see, when you run a.exe, nothing is printed because this condition is false, so the code inside the two curly braces will not be executed. And this is the whole point from using if statement. So if the condition is true, execute the code between these two curly braces, otherwise don't execute it. That's it for the if statement. This is the first case. In the next lesson, we will cover the second and third cases for if statements. If you have any question, feel free to ask. This is Asher from Educational Engineering Team. And welcome to this new lesson in which we are going to talk about the second and third case of if statement. Now, in this case, we have something called else if. Let's check it out. This is something we are already familiar with from the first case. If, condition, then execute the action. Now, if this condition is false, and you want to check another condition, in this case, you need to add else and leave a space, then add if. You will use the very same syntax, as you can see in this area. If the condition is true, then execute this action. The only thing that's new here is the else statement. Now, else here means that if this condition is not true, then go and check the other condition. But if this condition is true, then you shouldn't go and check other conditions. You need to make sure that you understand this point well. If you added else, it means that the first condition that will be true will mean that the program will execute the associated action and it will not check other conditions. Otherwise, you can use only if and you can get rid of the else if you want to check all of these conditions. So in this case, if condition is true, condition 1 true, it will not go and check condition 2. But if condition 1 is false, it will go and check condition 2 if there is an else statement before the if. Now, let's see this in action. Now, let's use the same code from before. This is if x is less than 50. Then go, write else if, and two parentheses and two curly braces. Now, here we will check if x is above or equal 50. Then in this case, we will print this. So x is less than 50 or else if this condition is false, then go and check this condition. If x is greater than or equal 50, then print this line. This is the use case of else if. It will check this condition. If it is true, it will not check this condition. It will just execute this line and it will go out of the if else statement. But if this condition is false, it will check the second condition. And if we have other conditions and this condition is false, it will check the next condition and so on. But you need to add the else statement before the if. Now, if you need the program to check all of these conditions, even if this is true and you need to check this one as well, you need to remove the else statement. And it will check the first condition, then it will go and check the second condition, and it will go and check the third condition, and whatever if statements that you added. But we usually use the else statement to reduce the CPU load and to reduce the amount of lines that we need to check and execute. So if this is true, there is no need to check this. Now let's try and execute this code. In here, write GCC 11 condition if else state.c. Write a.exe. Now, as you can see, it printed x is greater than or equal 50, which is this line. What happened here is that the program went through this one. It checked if x is less than 50, and this is false. So what happened here is that it didn't execute the printf function because this is false. It went to the second condition, else if x is greater than or equal 50, and this was true, so it executed this line, and this is what you see here. Now that leads us to the third case. The third case is simply the else case. In the else case, this is a line of code that you write to make sure that if none of the conditions is true, it will do something else. So if condition 1 is false, else if condition 2 is false, else if condition 3 is false, then go and execute whatever inside the else statement. You just write else and add two curly braces. Now to apply this to our code, you can simply go to the code, and in here you can write else and add two curly braces. Now between these two curly braces, you can write a printf function. None of the condition is true. Now let's make all of them false. So let's make it x is greater than or equal 60. So this one is false, else if this one is also false, so it will go and execute whatever we wrote inside the else statement. Save your code, go to the console window. Now let's compile the code. Here the screen, a.exe, and here it is. None of the conditions is true because the first condition is false. It went to the second condition, else if 50 is greater than or equal 60, it's also false. So it left the second condition and went directly to the else statement and executed the code inside it. So else statement is like a default case. If none of the condition is true, you need to write something inside here to show it to the user. Like if he wrote a wrong password for a specific number of times, or if he wrote the wrong password that you have checked using if and else if statements for different passwords that you have set, then you can write none of the passwords is true. And this is one of the use cases of else statement. It can also be used without the else if, so you can simply remove these two lines and leave it just if and else, and it will work without any problems. That's it for this lesson. Now to summarize things, if is used to check a condition. If you have more than one condition related to the same variable, you can use if and else if statements. If you have an action that you need to execute if none of the conditions is true, then you can write it inside the else statement between the two curly braces, and it will be executed if none of the conditions is true. One last note is, if the if statement is true, it will not go through the else if and else statements. It will just execute this action and get out of the if, else, if, and else block. And this is a good way to reduce the amount of time spent on checking the conditions. So if this condition is true, it will not check this condition and will not go to the else statement. We mentioned that if you wanted to check all of the conditions, you need to remove the else statement from here. And it will be just a normal if statement that checks the condition, and if the condition is true, it will execute the action. That's it for this lesson. If you have any questions regarding the if and else if statements, I'll be more than happy to help. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about some general rules when dealing with if statements. Now, the first rule is that else if and else are optional. Now you can use if statement without having to write else if or else if you have only one condition to check. These are optional add-ons that you can use depending on the use case or the end goal. Nested if is allowed, and nested if is basically writing an if statement inside another if statement, and I'll show you that in a minute. It is not allowed to write code between if and else if or else, because if you did write code, you will be separating the if from the else if statement, and it will show you a syntax error. Use round brackets to an if statement with several conditions to avoid technical errors. Some people use the if statements without writing the curly braces or round brackets, which cause a lot of syntax error and technical errors. And I'll talk about that in a minute. In case you only need one action in a multiple condition if statement, you may opt to not use a bracket, although it is still highly recommended. Now, let's see these notes in action. Now, let's write a new code. Let's add the main function. And let's choose the C language as our default language. Now int x equal 50. We need to check if x equals 50. Inside here, we will write if x is greater than or equal 50. Now, between the two curly braces, we will use printf function. And in here, we will write x equals 50. Now, what we meant with the fact that else and else if are optional is that you can choose not to use them and there will be no errors, no syntax errors and nothing. And what we meant with nested if is that you can write another if statement inside this if statement between these two curly braces. So you can go after this printf line and check using another if condition. If x, let's say that here we are checking if x equals 50 or greater than, let's say 50. Let's make it 60. And inside it, we need to check if x equals 50, let's say. And this will be our code. So we will print the same line, x is greater than 50, and here x equals 50. Now this if statement, as you can see, these are the two curly braces in red for the first if statement. Now inside it, we wrote another if statement, and these are the curly braces for the second if statement. And this is something we call nested if, which is writing an if statement inside another if statement. Now this is allowed and you can do it, and most of us do it to check multiple conditions. So when the first condition is true, we need to check if the second condition is true inside the first condition. Now this is the printf function that will be executed if x is greater than 50, which is the first condition. Now, inside the second condition, we add another printf function. So if x equals 50, or let's say 55, in this case, it will print the second function, which is the printf function. Now, let's try and execute this. Let's call this 12 if rules. Now, open containing folder and run it with cmd. Now here we will add gcc.c a.exe. As you can see, x is greater than 50 because x equals 60. But since x is not or does not equal 55, it didn't print the second if statement. So let's change this with 60 to see what will happen. Execute it and run. As you can see, here the first condition is true. X is greater than 50. So it printed this line inside the if statement, and inside it we have another if statement inside the first if statement, which is a nested if. This if statement will check if x equals 60, and that is true. So it will execute the second printf statement, and it printed x equals 55. And this is how to use nested if. Again, this is an if statement inside the first if statement. As you can see, this is the first if statement, and this is the second if statement inside it. It's not like the else if case. Now, it is not allowed to write a code between the else if, let's say x equals 10, and let's add anything inside here. So it's not allowed to write codes between this curly braces and the else if statement like this. If you try to write, let's say, a printf statement outside the first if statement and before the else if, let's try to execute our code. As you can see, we have an error. We have else without a previous if. So it's indicating the else if statement, which is this statement. This is because we added a line between the first if statement and the else if statement. So this new line breaks the block, the if and else if block. So this if statement is one block and this else if statement is another block. And you cannot use else if or else without an original if statement. That's why there is an error that else without a previous if is detected, and it showed you a syntax error. To fix it, you need to remove this and make them like stick together, and this will be treated as a block. Now, another thing is that you can use this else if statement without these two curly braces. Now you can remove them and you can just write this if and write the printf line. Now, I don't usually recommend this because it will give you a lot of technical errors and logical errors. Sometimes the code might work, but it will behave in a wrong way. So we usually prefer to add the two curly braces after the if statement. But let's say some rules if you want to use the if without the curly braces. The first rule is that if you wrote the if without the curly braces, you are only allowed to add one line of code. And to check this, let's comment all of these lines. So I will add a comment here and here. And let's use this statement. Now, if x equals 10, here you can write x equals 10 and it will be executed. Now, if you want to write another line inside the if statement, x indeed equals 10. Now, since you haven't added the two curly braces at the beginning and end of the action code, it will only execute this code. Now, let's check this inside the console window. Okay, now let's save the code. I haven't saved it. That's true. Okay, now it's saying that we have implicit declaration of okay, print. We need to add f here. It's a spelling mistake. Now let's execute this. As you can see, x equal 10, and this is true. So it executed the first line. Now the second line is not related to the if statement, and it was executed anyway. Now let's make the condition wrong. So if x does not equal 10. Now let's compile and run. As you can see, even though x does not equal 10, it did executed the second line, which is the printf statement, x indeed equals 10. This is because if we haven't added curly braces, if will only take one line after the if statement and treat it as if it follows the if statement. So if x does not equal 10, that is not true, so this line will not be executed. And this is the end boundary of the if statement since we haven't added the curly braces. This line is a simple line of code outside the if statement. It's like you have written this line of code away from the if statement, because if statement without the curly braces can only execute one line of code. Now if we wanted to execute both of these lines, we need to add the curly braces. Now when we execute the code one more time, it will print nothing because these two lines are related to this if statement. Let's try this out. As you can see, it didn't print anything. As you can see, both of these lines following the if statement, and it is false, so no lines were printed. But in the case of no curly braces, it did print the second line because we already mentioned that without the curly braces, if will only take one line after the if statement and treat it as if it is the line of code or the action that it needs to execute or not execute depending on the condition. Now, again, we don't recommend at all not using curly braces. Using curly braces is a good programming practice. Without them, you might end up having a lot of logical errors, but you need to know this piece of information because sometimes it comes in a multiple choice question or a quiz or exam or an interview. They will write if statement without the curly braces and tell you what is the output of this program. Now you need to understand that the if is only related to this line of code, and this line of code is not relevant to the if statement. That's it. Thanks for watching this lesson. If you have any questions, I'm here to help. This is Ashraf from Educational Engineering Team. Now and welcome to this new lesson in which we are going to talk about switch case. Now, switch statements is like if statements are used to check if a condition is true or not, then it will execute a command. The switch statement permits users to choose only one choice from a set of choices. The variable values are compared with the values in different cases, and then it matches the case value. In case there is no match, the default block is automatically executed. Now, to make things more clear, let's take a quick look at this diagram. Here is our expression, which is basically the variable that we want to check. Now, if this variable equals the first constant, let's say 1, it will execute code block 1. If it is not equal to 1, it will go to check the second constant. Let's say that it is 2. Now, if the variable value equals 2, it will execute this block. Otherwise, it will go to the third constant. And it can go on and on up to n number of constants. Now, if none of these constants or conditions is true, it will go and execute the default code, like the else statement and the if else statement. So if none of the conditions is true, go and execute the default code. That's it. Now, to make things more clear, let's see the syntax. First, let's add the include statement and add the main function. Now, change the language to C. Save the code as 13 switch state. Now, let's define a variable int x equal 5. Okay, let's make it equal 3. Now, this is the switch case syntax. First, you need to add the switch and 2 parentheses and 2 curly braces. Then start writing the inner syntax before writing anything inside the 2 parentheses. Here you write case and these 2 dots. Then you need to add break. The syntax is a little bit complex, but you need to memorize it as it is. Now you need to add another case depending on how many cases you need to add, and another break. Another case, and another break. And then finally, you need to add the default and break it. Now, let's start by adding here the variable that we want to switch over, which is x. Now, this is the first case. So, write anything inside here, but make sure that it is a constant. So, let's write 1. So, if x equals 1, then write your code here. Action 1. This is condition 1. Let's say that we want to use printf to print a function, to print something. Let's say x equals 1. Now, copy the same thing. Here we have the second switch case, make it 2, and say x equals 2. Here we have the third one, make it 3, and write x equals 3. Now if none of them, let's name this default action, and let's say that x value is not here. So if none of these is true, then it will execute this line. Now let's save this code. Let me explain the code blocks, then we can talk about each of these parts. Now as you can see here, we have the switch statement. Now what I need to understand is that between these two curly braces, we must add a variable that we want to check. Now there are two curly braces that everything else is placed inside them. Now the syntax is clear. We have a case and we must break it. Now the case ends with 2 dots while the break ends with a semicolon. Let me zoom in. Now the case, there must be a space after the case, then you can add the value that you want to switch over. So this will check if x equals 1. And if this is true, it will execute this action between the case and the break. Now, if this is false, it will go to the next case. Now, if this is true, it will execute this and get out of the switch statement, just like the if-else-if statement. Now, if this is false, then it will go and check the second case, if x equals 2. If x equals 2, it will execute this action. Then it will break from this case, and it will get out of the switch statement. Again, as you can see here, we have 2 dots, here we have a semicolon, and here we have a space between the case and the value that we want to check. Same thing for the third case, and you can add a fourth, fifth, and any number of cases. The last case will be the default case in here. Now the default case here is basically the else statement in the if-else statement. Now if none of these conditions is true, then it will go to the default case, and here we have 2 dots, and it will execute the action or anything written between the default and the break, which is this line of code. It looks like an if, else if, and else statement, but using a switch case. And it's a very familiar or a very famous way to switch over a variable to check if it is the right variable or not. And they usually use it when creating a menu for the user to check an item from. Now going back to our code, let's save the code and try to compile it. Now here we have GCC 13 switch state.c, write a.exe, and as you can see, this line was printed. And it was printed because x equals 3. So once we enter the switch statement, it checked if x equals 1. This is false, so it went to the second case, if x equals 2, which is also. So it went and checked if x equals 2, which is false, and it went from this case to the next case to check if x equals 3, which is true because x equals 3. So it printed this line between the case and the break, and if we wrote any other line inside here, it will be printed and executed. And once this or one of the cases is true, it will execute the code inside the case and it will get out of the switch statement. So it will not check the default and it will not execute the default. That's why we have x equals 3. That's it. This is the switch statement and this is how to use it. If you have any questions regarding anything, I'm here to help. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about switch statement general rules. These are rules that you must take into consideration when you are dealing with switch statements. Now, we'll talk about the constant for each of these cases. Number 1, 2, 3. This constant must be unique, so you cannot use the same constant twice, like 1 and 1. This is wrong. And you cannot add a variable here, like y, or x, or a. It must be a constant value. A default label is optional, so you can use this default label with a break statement, or you can delete it. The switch case statement will work without any issues. And this is a good point to keep in mind. Now, only one default is allowed, so you cannot add a default here and add a default here. This will give you a syntax error because it will disturb the program. It won't know which of these defaults to be executed. So we have only one default. Now, second thing about the default is that it can be placed anywhere inside the switch statement. So you can place it here, or you can place it here. As long as it's only one default, it is allowed to place it anywhere. So make sure that you add it whenever you want. Just make sure that it's not duplicated. Now, the break statement ends with switch. Each of these cases must have its own break statement. So in this case is true, it will execute this code, then break the switch statement altogether. So it will get out of the whole statement. If you forget to add the break statement, this will cause logical errors. In case a break statement does not exist, like if we remove this break statement, all subsequent codes shall be executed until the end of switch or until the program finds a break statement. So it will execute this, then go and execute this until it reaches the break statement. So make sure that you don't forget any of the break statements. Each case must have its own break statement, and I usually write the whole syntax first, then I start to code. Another good thing that you need to know is that nesting is allowed. And what we mean by nesting is that you can write a switch statement inside any of these cases. Let's say that we are inside case 2. We can easily write switch and case 0 break, and we can add another variable here, let's say y, and switch using this variable default, and after default we have the break. Now this is allowed inside any of these cases, and this case is called nested switch statement. So it's writing switch statement inside the original switch statement. Now, to summarize, our case constant must be unique and it cannot be a variable. A default label is optional. Only one default is allowed, however, it can be placed anywhere in the switch statement. A break statement ends the switch. In case a break statement does not exist, all subsequent codes shall be executed until the end of switch or finds a break statement. Nesting is also allowed, just like we showed you a few seconds ago. These are the main rules that you need to keep in mind. Usually, most of them come in multiple choice questions, in true and false questions, or interview questions regarding programming in C. If you have any question about any of the things that we explained, I'll be more than happy to help. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about loops. Loops in C. Loops are a part of C programming that are used to repeat a specific block of code. There are two main reasons to use loops. The first one is to repeat the code for defined number of iterations. For example, repeating a part of the code 10 times. We often use for loop in this case. The second reason is repeat the code until a certain event happens. For example, repeating a part of the code until user enters X. We often use while loop or do while loop in this case. We will talk about these three types of loops in a minute. Now, the first type that we will cover in this lesson is for loop. For loop is used to apply the code for defined number of iterations. This loop take this syntax. Now, let's discuss the syntax. The first part is writing the for itself. It's called for loop. Then we add two parentheses. After that, we will add two curly braces. Now, we will add the code that we want to repeat for a certain number of times between the two curly braces. Now, between the parentheses, we need to add two semicolons, here and here. The first part between the first parentheses and the first semicolon is the start condition. Now, this will be the variable initialization, like we want the variable to start from 0. Between these two semicolons, we will add the condition. And the last step is between this semicolon and the closing parentheses is adding the action, which is basically increasing the variable or doing anything. Now, let's look at this example to understand the syntax. First, we created a variable. The name is I, the type is integer. Then, we added the starting point here. I equals 0, which is the starting point for the number of iterations that we want. Here is the condition. As long as I is below 5 or is less than 5, this block of code will be executed. So first it will make I equal 0, then it will check the condition. 0 is less than 5, that's true. After that, it will go and execute the action. Once this code is executed between the two curly braces, this one and this one, it will go back to this action. This action is executed after executing the loop body statement. So it will increase I by 1. So I in the first iteration was 0. Now I equals 1. Now once I equals 1, it will go back to check the condition. It will never go back to the start action ever again. The start action is only executed at the beginning of looping. Now, 1 is less than 5, that's true, so it will go back to executing the loop body statement. Once done, it will go back to the action to increase I by 1. Now I equals 2. Then it will go and check the condition. 2 is less than 5, so it will go and execute this command. Once done, it will go back to the action. I will be increased by 1. It will go back to the condition. 3 is less than 5, that's true, so it will execute the loop body statement, go back to the action. I equals 4. So it will go back to the condition. 4 is less than 5, that's true. So it will execute this line again. And it will go back to the action I plus plus, so I equals 5. Now in this case, 5 is not less than 5. So the condition will be false and it will not execute the loop body statement. It will go out of the loop. That's it. This is how easy it is to understand the for loop syntax. The start condition is only executed once when we first start playing the loop. Then it will check the condition. If true, it will go execute the code, go to the action, then go back to the condition, check if true, execute the code, go back to the action, then check the condition, and so on. It will keep looping in this until the condition is false, then it will go out of the loop. Now, to make things more clear, let's take a practical exercise. Now, as usual, let's hash include create the main function, choose the language to be C, and in here, int I equals 0. Let's do the same example, then we can make a new one. I equals 0, which is the start condition. I is less than 5, which is the condition itself, and the action is I plus plus. Now the code that we want to execute is the printf. This is me inside for loop. Condition is true. And add /n. Now let's save it. 14 for loop. Let's run the code. gcc.c a.exe. As you can see, this is me inside the code. It was executed 1, 2, 3, 4, 5 times from 0 to 4. This is 0, this is 1, 2, 3, and 4. Once I equals 5, the condition will be false and it will get out of the loop. Now we can spice things up, like by adding I and printing it inside the loop. So this is me inside the loop. Condition is true. Let's add them. I equal %d. Now to print I, all what you need to do is add I here. It will %d will replace I value and print it inside this line. So save your code, go back, compile, then run. As you can see, I equal 0, I equal 1, I equal 2, I equal 3, and I equal 4, which is what we explained in the previous explanation at the beginning of this lesson. Once I equals 5, it will not execute the loop body statement, it will exit the loop. Now, another cool thing that you can do is you can, let's say, print the values or print a name 100 times with just 2 lines of code. So let's add this as 500, which is the condition, as you can see. So this line will be printed 500 times. Let's see gcc a.exe. As you can see, from 0 to 499. So we just printed 500 lines with just 2 lines of code. As you can see, from 0 to 499. And you can increase the number, which is here in the condition. Now, a few things that we need to mention is that the start is only executed once, then it will keep looping between the condition the loop body statement and the action, then the condition, loop body statement, action, condition, loop body statement, action, and so on until the condition is false. That's it for this lesson. If you have any questions about for loop, I'm here to help. Again, for loop is used to print, let's say, a value or a line or a piece of code for a specific number of iteration. In the next lessons, we will talk about loops that are used when we want to focus on the condition. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about loops. Loops in C. Loops are a part of C programming that are used to repeat a specific block of code. There are two main reasons to use loops. The first one is to repeat the code for defined number of iterations. For example, repeating a part of the code 10 times. We often use for loop in this case. The second reason is repeat the code until a certain event happens. For example, repeating a part of the code until user enters X. We often use while loop or do while loop in this case. We will talk about these three types of loops in a minute. Now, the first type that we will cover in this lesson is for loop. For loop is used to apply the code for defined number of iterations. This loop takes this syntax. Now, let's discuss the syntax. The first part is writing the for itself. It's called for loop. Then we add two parentheses. After that, we will add two curly braces. Now, we will add the code that we want to repeat for a certain number of times between the two curly braces. Now, between the parentheses, we need to add two semicolons, here and here. The first part between the first parentheses and the first semicolon is the start condition. Now, this will be the variable initialization, like we want the variable to start from 0. Between these two semicolons, we will add the condition. And the last step is between this semicolon and the closing parentheses is adding the action, which is basically increasing the variable or doing anything. Now, let's look at this example to understand the syntax. First, we created a variable. The name is I, the type is integer. Then, we added the starting point here. I equals 0, which is the starting point for the number of iterations that we want. Here is the condition. As long as I is below 5 or is less than 5, this block of code will be executed. So first it will make I equal 0, then it will check the condition. 0 is less than 5, that's true. After that, it will go and execute the action. Once this code is executed between the two curly braces, this one and this one, it will go back to this action. This action is executed after executing the loop body statement. So it will increase I by 1. So I in the first iteration was 0. Now I equals 1. Now once I equals 1, it will go back to check the condition. It will never go back to the start action ever again. The start action is only executed at the beginning of looping. Now, 1 is less than 5, that's true, so it will go back to executing the loop body statement. Once done, it will go back to the action to increase I by 1. Now I equals 2. Then it will go and check the condition. 2 is less than 5, so it will go and execute this command. Once done, it will go back to the action. I will be increased by 1. It will go back to the condition. 3 is less than 5, that's true, so it will execute the loop body statement, go back to the action, I equals 4, so it will go back to the condition. 4 is less than 5, that's true, so it will execute this line again, and it will go back to the action, I plus plus, so I equals 5. Now in this case, 5 is not less than 5, so the condition will be false, and it will not execute the loop body statement, it will go out of the loop. That's it. This is how easy it is to understand the for loop syntax. The start condition is only executed once when we first start playing the loop. Then it will check the condition. If true, it will go execute the code, go to the action, then go back to the condition, check if true, execute the code, go back to the action, then check the condition, and so on. It will keep looping in this until the condition is false, then it will go out of the loop. Now, to make things more clear, let's take a practical exercise. Now, as usual, let's hash include create the main function, choose the language to be C, and in here, int I equals 0. Let's do the same example, then we can make a new one. I equals 0, which is the start condition. I is less than 5, which is the condition itself, and the action is I plus plus. Now the code that we want to execute is the printf. This is me inside for loop. Condition is true. And add /n. Now let's save it. 14 for loop. Let's run the code. gcc.c a.exe. As you can see, this is me inside the code. It was executed 1, 2, 3, 4, 5 times from 0 to 4. This is 0, this is 1, 2, 3, and 4. Once I equals 5, the condition will be false and it will get out of the loop. Now we can spice things up, like by adding I and printing it inside the loop. So this is me inside the loop. Condition is true. Let's add them. I equal %d. Now to print I, all what you need to do is add I here. It will %d will replace I value and print it inside this line. So save your code, go back, compile, then run. As you can see, I equal 0, I equal 1, I equal 2, I equal 3, and I equal 4, which is what we explained in the previous explanation at the beginning of this lesson. Once I equals 5, it will not execute the loop body statement, it will exit the loop. Now, another cool thing that you can do is you can, let's say, print the values or print a name 100 times with just 2 lines of code. So let's add this as 500. which is the condition, as you can see. So this line will be printed 500 times. Let's see GCC a.exe. As you can see, from 0 to 499. So we just printed 500 lines with just 2 lines of code. As you can see, from 0 to 499. And you can increase the number, which is here in the condition. Now, a few things that we need to mention is that the start is only executed once, then it will keep looping between the condition, the loop body statement, and the action. Then the condition, loop body statement, action, condition, loop body statement, action, and so on until the condition is false. That's it for this lesson. If you have any questions about for loop, I'm here to help. Again, for loop is used to print, let's say, a value or a line or a piece of code for a specific number of iteration. In the next lessons, we will talk about loops that are used when we want to focus on the condition. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to discuss the do-while loop. Now, it is very similar to while loop, but since we have a do before it, then there is some changes or some differences, let's say. Now, let's look at the syntax. As you can see, it starts with a do, then 2 curly braces. Now, the condition is the last thing written here. As you can see, these are the 2 curly braces. Then we have the block of code. After that, we have the condition, which is while, 2 parentheses. And between the 2 parentheses, we have the condition. And here we have a semicolon. Now, this is the syntax, and you must memorize it. Since we have the do, and we have the curly braces with the block of code prior to the while loop or the while condition, this means that the loop body statement will be executed at least once before checking whether the condition is true or not. This is because we have the condition here at the end. And this is the main difference between the while and do-while loop. So the do-while loop executes the code block prior to checking whether the condition is true. It will continue to repeat the loop for as long as the condition is true, just like the while loop. The string in this case, let's see this example. Here we have an integer x equals 1. We have do 2 statements, and we have this condition. Now, the first thing that will happen, it will go to the do, then it will execute these 2 lines before checking the condition. So it will print and scan. It will print I'm in the loop, then it will scan something from the user, let's say a number. Now, while the number that was scanned is not equal 0, so while this condition is true, just like in the while loop, it will go back and execute the code block again. Once it finishes the execution, it will go to the condition, and it will keep looping like this, then like this, like this, then like this, and so on, until the condition is false. Just like what we explained in the while loop, except that in this case, if the condition is false from the beginning, the code block will be executed at least once, because we are executing the code block before even checking the condition, whether the condition is true or false. And this is because we are starting with the do, then the while. Unlike the while, which is the second type that we explained. Now let's take a look at a practical example. First, let's include the stdio.h void main. Here we need to add void, and let's choose the language to be C, int x equals 1, do while, and the condition is x not equal 0. Now this is the syntax. Now press enter here, and here we need to add the code block. Let's add a printf statement inside the loop, then scanf to read an input from the user, and let's say x. X %d. Okay, now let's say that enter x, then /n without a slash n. We will leave it like that in the same line. Now let's save it. Let's call it 16 do while. Now let's go to the compiling process. Now go to the file, open containing folder, cmd, gcc.c, a.exe. We are inside the loop, enter x, so x, let's say equal 1, 2, 3, 4, 5, 6. As long as x is not equal to 0, it will keep doing that. Now once x equals 0, now here's the condition. X not equal 0. Now if x is 0, so 0 equals 0, so this condition is false. It will get out of the do while loop. So let's write 0 here. As you can see, it's out. Now let's say that we want to make the condition false from the beginning. So let's say that x not equal 0, and here we have it, x equal 1. Now, as you can see in this case, now if we enter 0 here, let's go to the execution, a.exe. Now if we entered 0 here, it means that 0 not equal 0. Now we already have this condition as false because x equal 1 and 1 not equal 0 is true. So if we replace this with 0, let's say, we save the code. So this, if it is a while, not a do while, nothing will be printed. But since we are using do while, and we already mentioned that the code block will be printed prior to checking whether the condition is true or not, the condition is false. It's not true because, as you can see here, 0 not equal 0 is false because 0 equals 0. So the condition is false and nothing should be executed. But since we are using do while, it will be executed at least once, even if the condition is false. So let's compile the code, run it. As you can see, we are inside the loop, enter x. Even though the condition is false, we are getting the code block executed, as you can see in this line. And this is the main difference between the do while and while. Now if we are using the same code, like this code, I will copy it as it is, the while, and here I will add the 2 lines, these 2 lines. Now let's comment this part, the do while, and let's play the while itself. Now if we save this code, go back to the execution, let's clean. Now a.exe, as you can see, nothing was printed here because the condition is false. And since we are checking the condition in the while before executing anything, nothing was printed. But in the do while, this was printed even though the condition is wrong. And this is the main difference between these two. I hope that now you are getting what I was trying to point out from the explanation. Now if you have any issue or any problem understanding the do-while, I'll be more than happy to elaborate. Questions and assignments will follow to make you understand things even more. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about break and continue. Now, break statement is basically writing break and adding a semicolon. Break statement can be used with the loop to exit the loop immediately and execute the outside code starting after the loop. While the continue statement, which is basically writing continue and adding a semicolon, will skip the current iteration and jump to the next iteration. So it will skip this code and go directly to the next iteration. The purpose of the break statement here is to break out of a loop early. For example, if a code is asking a user or the input to enter an integer named x, and this condition is true, it will break the while loop. Now, to make things more clear, let's take these two examples. This is an infinite loop. An infinite loop is basically a loop that will repeat forever. So this code will keep repeating forever. Because while 1, and we already know that any number that is not 0 is true. So 1 here means while true. So this condition will be true forever. That's why we call it infinite loop. This loop will break once the user enter x as 1. So it will wait the user to enter something, anything. Now, if the thing that the user entered equals 1, it will break from the loop. Now, that's it. The loop will end without having to make the condition false. Now, for the continue statement, let's say that this is a for loop that loops from 1 to 9, since I is less than 10. Now, it will keep executing this code with each iteration, just like how we explained in the for loop lesson. Now, this statement, if I equals 6, will check once once the iteration reaches the 6, or I equals 6, it will skip this iteration. And when we say skip, it will not execute anything in here. It will just jump to the action and increase I to 7. So this line will not be printed when I equals 6. And this is what we mean by skipping iteration using the continue statement. Now, to make things more clear, let's do this using a practical example. Now, let's start by adding our hash include. As usual, void main void. Now, here between the two curly parentheses, or curly braces, we need to add our code. Let's change the language to C. Now, we need to create while loop to test the break sentence. Now, inside this while loop, we need to make it infinite loop, and we need to read input from the user. Here, we will write %d, and let's say m. And let's create a variable, call it m, give it an initial value of 0. Now, inside here, we need to check if m equal 1, then break. Now, you can add it in the same line, or you can add it underneath it. As long as it's only one line, it will be executed without the curly braces, as we mentioned in previous lessons. Now, if you try to test this code, let's first save it. Now, save the file. Go to File, open containing folder, cmd. In here, let's zoom in, file gcc, and the file name 17 break continue .c, now a.exe. As you can see, it's waiting for us to enter something. Let's enter 5, then enter 6, 7, 8. It will keep asking for more. It will keep scanning the incoming values since we are inside an infinite loop. Now, once I write down 1, it will break from the while loop. And break statement basically is used to exit while loop immediately and execute the code outside. Since we don't have any code, it will go outside the while loop and finish the program. So let's write 1, enter. As you can see, now it's out. So it went outside the while loop and the program finished executing. So this is the main purpose from using the break line. It's basically to break out from a loop or let's say infinite loop or a condition. Now this is the first thing. Let's test the continue statement using a for loop. So here is our for. Inside here, int I equals 0, I is less than 10, I plus plus. So here we are going to ask if I equal 5, then continue. Now, before moving forward, we need to add the print statement. So printf, let's say %d /n, and in here we need to print the value of I. Now this line does not exist. Let's see the output in both cases, without the continue and with the continue. Now this will print values from 0 to 9. So let's go file, open cmd, gcc, 17 break continue .c. Okay, maybe the continue. Now a.exe, it will print values from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if we enable this, once I equals 5, this condition will be true. Continue will skip this, anything inside the loop, and it will go to the increment or the action block of the for loop. So it will not execute any code when it reaches the I equal 5. So 5 will not be printed. So let's test it out here. Let's save the code. Now go back, compile it, execute it. Now as you can see, let's compare them. Here you can see 0, 1, 2, 3, 4, and here you can see them. Now 5 is here in the previous execution without this sentence, while here we don't have 5. We have only 6, 7, 8, and 9. So it did skip 5. Now we already mentioned that continue statement will skip the current iteration and jump to the next iteration. And this is what happened here. That's it. This is the break statement, which breaks out of a loop if the condition is true. This is the continue statement, which is basically a statement that is used to skip a specific iteration inside a loop. That's it for this lesson. If you have any questions, I'm here to help. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson, which is one of the most important lessons in this course. In this lesson, we will talk about functions. A function is a block of code which only runs when it's called. It is used to perform certain actions, and they are important for reusing code, like define the code once and use it many times. To use the function, you need to call it inside your code. When calling a function, you may send some data or some input, and it could return back an output for you. The most common function is the main function, which is the entry point that we have been writing since the beginning of this course. Now, our main function is basically this. We write it like that: void main, 2 parentheses, and 2 curly braces. Now, this is the function name, and main is reserved for the main function, which is the entry point. Between the 2 parentheses, we add the input. Now, if we don't want to add any input, we add the word void. Now, this is the returning data type. If this function does not return anything, then we call it void. We add void in the return data type. And the code that you want to execute or reuse, you usually write it inside here. This is the code. Now, this is one of the functions that we have been using a lot since the beginning of our program. To execute the function, you will need to call it. The function provides you with the advantage that it is defined one time and can be executed many times, so it takes the same size in the memory, whatever how many times it will be called. When you call a function, you can send to it some inputs, as we already mentioned, and the other example for a function that we have been using since the beginning of our coding process is the printf function. Now, printf function is basically a function that takes input between the 2 parentheses, and the execution of this function will print output on CMD, which is the command line window. Now, the print function takes a string as an input argument and print it on the screen. Any C project composed of one function or more, which are basically the main, print, and scanf. Now, printf, scanf, main, all of these are called C programming functions or built-in functions, because we do not create these functions, we only use them, we call them by their name. But if you created a function, let's say that you call the function Ashraf, then this is called a user defined function. So anything that you create is called a user-defined function. Anything that you use and it's already created by C compiler or C programming language is called a built-in function or a C programming function. Now, to make things more clear, we need to talk about what should you do if you want to create your own function. Well, if you want to create your own function, you need to understand that a function consists of 3 parts, and you need to memorize these parts. The first part is the prototype. And this prototype declares the function. So it tells the compiler that there is a function with this name and these specifications. Usually, the prototype includes the return type, as we already mentioned, the function name, 2 parentheses here and there, and the input between the 2 parentheses, then the line ends with a semicolon. This is called a prototype. Now, this is the first part. The second part is called the implementation, and it's basically the place where you write the function code. It defines the function behavior. And it has the very same shape as the prototype, as you can see, except for the semicolon. Here we don't have semicolon. Instead, we have the two curly braces. Inside them, we will write the function code. And you can see that here. Here we have the first curly brace, here we have the second, and between them, we usually write our function statement or code. Now, this is the second part, which is basically writing down the function itself with the code that we need to execute. Now, the third part is the function call. The function call includes the function name and any inputs between the two parentheses. And if it returns something, we need to store the data that this function returns inside a variable. Now, if it does not return anything, we don't need to store anything. Let's do a quick revision. A function that you create consists of three things that you need to write down. The first thing is the prototype, which is basically a way to declare the function. It's a line that ends with a semicolon, and it includes the return type, if any, the function name that you define, and two parentheses with an input between them, if there is any. Now, if there is no input, you need to write void, and we will cover this in a separated lesson, the meaning of a void data type. Now, after writing the prototype, we need to write the implementation, which is the function body. We use the same line as in the prototype, but instead of ending the line with a semicolon, we end it with two curly braces, this one and this one. Between the two curly braces, we write the function code. The third step is the function call. Inside our main, we can call our function with its name. So function name, and we send two inputs. Now I know that things might not be clear, so let's take an example to make things even more clear. Now, this is a function that we defined, and we are going to execute in few seconds. The first part here is called prototype. This is a line. This is the return type. This function will return an integer. This, the subword, is the function name, which is the second part of the prototype, as we already mentioned. Now we have two parentheses, as you can see here and here, and these two parentheses will end with a semicolon. Now this function will take two inputs. Now it can take more than two inputs depending on our program and our code, but you need to make sure that you have a semicolon between each of these inputs, and you have the type and the name for each of these inputs. So we have the data type for the first input integer, and the name is x, a comma, then the data type of the second input is integer, and its name is y. And the second thing, now this is the first thing that we have, it's called the prototype, as we already mentioned. Now the second thing is the implementation. This is number 2. And as we already mentioned, the first line is the same. It's a common thing between the prototype and the implementation, except for the semicolon. We have to remove it. And after that, we add two curly braces, and between them we will add our code. Now this is the code that you can reuse, and this is the function name. This is the return data type, and these are the two inputs. This function will subtract x minus y. So we'll create a new variable inside the function. It will equal x minus y. So the result will be inside z. And since this function returns an integer, we need to return the summation value. And we end the line by a semicolon. So this is our code. This block is called implementation. which is the second thing that you must do. This is the first thing. Now the third thing is the function call. Now, as you can see, the function call is simply calling the function with its name. Here we have the function name, we have the two parentheses and the semicolon. But instead of adding int x, int y, we are adding two values to be passed to the function, and you need to add the semicolon. Now, can you pass variables? Yes, you can replace these with x and y, or a and b, or whatever you want, but you need to make sure that there are only two inputs, since the function takes only two inputs, and you need to make sure that the variables are integers and have values. Now, once you send the values to this function, you can call it, which is the third thing. We call this a call or function call. Function call. Now, the function call is basically calling the function code. So it will give 5 and 2 instead of x and y, and 5 will be here, 2 will be here. 5 minus 2 equals 3. So z will equal 3, and it will return 3. Now, when you call the function, it will return an integer. So we need to create an integer variable. We called it var, to store the value that will be returned by the function. And in this case, it will be 3. So var will equal 3. And when we print this, it will print result is 3. This will be the output in our console window. And here we call the function, as you can see in this line, inside the main function. You can call it again and again and again without having to write the whole function each time you call it. You just write it once and you can call it, let's say 10 times, 20 times, whatever you want. Now, to make things even more clear, let's implement this exercise in our Notepad++. Now, to do this, we will start with the usual thing. We will include the stdio.h. Now, the first thing that we need to do is add the void main void, which is our main function. Now, what we will do next is simple. We will add the function prototype. Usually the prototype is written above the main. So here, function prototype. So the function will return an integer, and its name will be sub. It will take two inputs, int x, int y, and we will end it with a semicolon. Now, the second step, this is the first step. The second step is writing the function itself underneath the main, outside the main and underneath it, as you can see, or below it. We are outside the main. Here, write 2, implementation. Now, what you need to do is simply copy the whole line here from the prototype, paste it here, remove the semicolon as we already mentioned, add two curly braces. Now, you need to make sure that this is identical to this, except for the semicolon. You have to remove it. Now, this function will subtract x minus y, a simple C code, and whenever a function returns something, it must contain the word return. It will return this value, z. Now, let's go to the last step, the call. So let's say we want to call this function, give it 5 and 2. Now, if we did this and we executed the code, nothing will happen. This function will subtract 5 minus 3. It will minus 2, it will equal 3, and the 3 value will be floating in the memory. So in order to control or to save the result from this function, we need to store it inside a variable. Let's call it var, and it must be the same data type as the return data type here, 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 and here. So it returns integer, so we need to receive the returned value inside an integer. Now once we have the returned value from the function, this is the function call, the third step, by its name, we can print it out using a printf statement. Result equal %d, and here we need to add the var. That's it. Let's save the code. Let's call it functions, function test. Now let's compile it. GCC C a.exe. As you can see, result equal 3. Now we can play a little bit with this code. You can pass variables instead of constants. Let's say that we want to ask the user to enter 2 values. So enter first number, and we will take it with a scanf statement. %d, let's call it and first num. Now let me define 2 variables. Integer first number equals 0, integer second number equals 0. Now this is the second number variable that we want to store the second value inside, and let's call it second. So here is the first number, here is the second number. Now we will call the function, and instead of adding the 2 constants, we will add the first number and the second number that the user entered. Then we will print out the result. Let's add /n here, another /n here, and another /n here. Now let's call this again, compile it. As you can see, enter first number, let's say 10, enter second number, let's say 4. The result equals 6. As you can see, it was implemented without any issues. So a function call can take constants and can take variables as long as these variables are of the same type as the implementation and the prototype. Always make sure that you are using the same type or the same data type, or else you might end up with syntax or logical errors. This is how easy it is to create a function, a user-defined function. As you can see, this is the first step, function prototype, the return data type, the function name, and the 2 inputs, end it with a semicolon. The second step is the implementation, which is the function itself. This is above the main, and this is under or below the main. The same as the prototype, but instead of semicolon, you need to add 2 curly braces and add your code inside it. The last step is the function call, which is basically calling, just like calling someone, calling a function by its name, passing the 2 inputs, and getting the result that it will return, storing the result inside the int var, which is the variable that we want to store the results in. That's it for the functions lesson. If you have any questions, please ask in the Q&A board. I'll be more than happy to help. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about void keyword. We already mentioned void and we talked about it in more than one lesson, but in this lesson we'll talk about it in more details. The void keyword is used to any function to give the meaning of nothing. For example, a function that takes void and returns void is in front of you. As you can see, this is the return data type as we mentioned in the previous lesson, and it's void. Now, it also takes void between the two parentheses. The only goal from this function is to print mic. Now, this can be changed with anything, but this function will never return any variable or any value, and it will not take any input values. So for example, if we need to define a function that takes no arguments, we would write between the two parentheses the void keyword, just like in this example. If we need to define a function that does not return any output, we will write instead of the return type the keyword void. And this is the void return type. The function can neither take input nor returns output. And this is basically the whole meaning of void. It means nothing. So if you saw the word void anywhere, it means that this place will take nothing or it will return nothing. Now, this is another example. This is a prototype for a function that returns nothing and takes nothing. That's why we have void here and here. The name of this function is print by name. Now, as you can see, this is the implementation of this function, and we use the same prototype, but we add two curly braces instead of the semicolon, and inside it we add the print statement. Now, the last thing is the call, and calling a void function is easy. You just call it by its name without writing anything between the two parentheses because it doesn't take any output, and without receiving a value from this and storing it into a variable. So to call a function that takes void, then write its name and write nothing between the parentheses, just like in this line. And if the function returns void, like in our example, then don't receive its output in a variable, just call it as it is. Now let's do this in a practical manner. Let's draw our own void function, or let's simply write, our own void function. Now let's add the hash include that we are used to. Let's zoom in and add stdio.h. Let's save the file and call it, let's void keyword.c. Now, inside here, after using the hash include, we need to call the void main function. Now, the main function can be void or can be int. Let's add void. This is the syntax that we usually use. Now, let's write the prototype here. Void print name and void. Now the file name, as we mentioned, is void keyword. Now let's copy the prototype, paste it down here, and remove the semicolon, add two curly braces, and add printf. My name is Dash. Now, to call, this is the first step, this is the second step. The third step is calling this function inside the main. So simply call it by its name, print name, and add two parentheses without anything inside them, and it won't return anything here. Save. File, open containing folder, cmd. Let's copy the name, gcc, and the name. Let's remove these two. Now a.exe, and as you can see, it executed this function. This is a function that takes nothing and returns nothing. We call it a void function. And this is how easy it is to implement it. So now whenever you see the word void, it means nothing. Don't input anything, won't return anything. Thanks for watching this lesson. If you have any questions about the void function We are here to help. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to talk about local variables and global variables. This is a very important concept when programming in any language, not just in C. Now, let's talk about local variable. A local variable is the variable that is defined inside any function. This variable can be accessed only on the function that defines it. So as you can see here, we have a local variable. It's integer x equals 10. So the type is integer, the variable name is x, and the value is 10. Now this function can only be accessed and seen inside the func. This is the only function that sees this variable. This is why we call it local variable. Now, the local variable can be seen only between the two curly braces on which it was defined. So as you can see, from here to here. That's why it's called local. Now, the global variable, on the other hand, is the variable that is defined outside a function, and this variable can be accessed in any function in the code. So let's take a look to the right here. We have integer x, and it's defined outside the main function and outside function 1. Since it's defined outside of them, it can be accessed by the main and it can be accessed by func1. And this is how great global variables are. They can be used anywhere inside your code. That's why they are called global. So whenever you want to create a variable and use it inside more than one function, you need to create it outside the functions at the beginning of your code, usually after the hash include. But if you want a variable to be accessed only inside a specific function, then create it inside the function itself, and in this case it will be a local variable. Now, to make things more clear, let's take a practical example. Let's create a new project. Hash include now void or int main void. Go to the language C. Let's save the code. Let's call it local global .c. Now let's create a variable here, int x equal 10, and let's print it. Now I'll print it the regular way, x. This is the file name. Now if we try to execute this code, it will execute without any problem. This is a local variable. And it can only be accessed between these two curly braces. Now if we were to create another function, void, this is the function prototype, print x, void. Now let's make the implementation here and add the same line, print fx. As you can see, this will try to print the variable x even though it wasn't defined in this scope and even though it is a local variable. And we already mentioned that this function will have no access to this variable since it is a local variable. So let's call the function print x So this is the prototype, as we mentioned. This is the implementation, and this is the function code. Now save the codes, go to File, CMD, okay. GCC. Okay, now let's look at this error. In function print x is undeclared. And this is because we are trying to access the local variable that was created inside the main function, inside another function. And this is not possible because this is a local variable. Now, let's create a global variable. In here, write int y equal 15. And let's add y here. So this will print the local variable, and this is our global variable. Now if we went back to the C code, it will compile without any problem, as you can see. Now you can write a.exe and it will print x and y. Now y can be accessed in the main function and in the print x function because it's a global variable, while x can only be accessed inside the main function. And this is the main concept of local variables and global variables. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team.